Okay, good morning, everyone. Welcome to this seminar. First of all, it's my honor to introduce Ark, Mr. Ark Tsisserev.
Tsisserev, yeah. It's Greek and Russian. Tsisserev means Caesar.
Okay, Caesar.
But it's a Greek origin.
Okay.
Caesar.
Yeah, Caesar.
Yeah.
So,
Emperor.
Ark is technical committee chairman of Canadian Electrical Code. He's also electrical subcommittee chairman of National Building Code, correct?
I am chair of liaison subcommittee between electrical code and building code.
Yeah.
Because I'm a fire protection engineer as well.
Okay. Yeah. So Ark was the former Winnipeg Chief Electrical Inspector and the former Chief Electrical Inspector of City of Vancouver, right? He was Stantec corporate electrical discipline lead. Ark was well respected by everyone in electrical industry for his knowledge, his experience, and his professionalism. But what most stood up to me is that Ark always liked to share his knowledge, his experience, and he always liked to help others. I would know Ark since 2010, when we were both still work for Stantec. At that time, Ark was Stantec corporate discipline lead, and I was electrical discipline lead in Ottawa office of Stantec. Ark has been my great teacher and friend for more than 10 years. He helped me a lot. I learned a lot from him. Today we are lucky to have Ark here to share with us his more than 50-year professional and hands-on experience in
1962.
Yeah, in electrical industry. Let's welcome Ark. Okay, so we can go back to the seat.
Folks, what we'll do today, George asked me to give basic feeling about changes to 2021. So why do we change codes? Every 3 years. It's like shoes, it's like pants. Why? Because we continuously improve code. By improving, we recognize new technology comes up. We have to implement this new technology in installation standards because products for this new technology exist, but rules are silent. It looks like code becomes obstacle to trade. We cannot install this new product because we don't have rules. And we have some changes, you will see. Second, we have to correlate Canadian electrical code with other codes, with building codes, some changes, and you'll see it happen. But most important, you will not believe, we made so many mistakes in existing codes, and we have to clean them up. So 60% of changes, it's a result of mistakes. How changes works? Committee works constantly without any interruptions. And normally committee, according to rules of code development, committee meets every year, and every year committee approves proposals. So let's say George or John wants to just send a proposal, just a proposal. He wants new installation, new receptacles. Receptacles must be installed not lower than 450 millimeters. So proposal must be substantiated. Comes to appropriate subcommittee, in this case, section 26. And subcommittee will look at it. Subcommittee may argue, may say, no, substantiation is not clear. There is not a reason for it. No safety, no economics, no correlation. Maybe it's not worth it. and subcommittee said reject. In the majority of cases, subcommittee accepts proposal, but modifies it because original wording is not consistent with text of the code. So makes editorial changes or some technical changes. And then subcommittee makes recommendation. It's a consensus-based, it's a team approach. So you understand how code changes. I'll give you one example. One contractor 10 years ago called me and he said, Ark, it's WP, Western Pacific Enterprise, it's a big company. And they were doing a big project downtown. He said, Ark, I just can't stand it. We protect equipment with sprinkler-proof shields in service rooms. Why don't we protect equipment which is not in service rooms? I said, hi, welcome. For 20 years, I'm trying to believe this rule doesn't work because I'm too close. So what I'll do, I'll make a proposal and send it to you. You send it to Canadian Standards Association because for me, I'm too close for them and they don't want to do it. You are fresh, you're superintendent, and I will support you. And of course, my inspector said, no, we don't want to do it. And the question is why? What's the reason? He is a piece of equipment in a service room. He is a piece of equipment outside of service room. He has to be protected by some stupid shields. And yet we've got connectors, dry connectors, water will come. And if sprinkler will spray, regardless, all equipment will have to be replaced. Because after it's sprayed, most of equipment will lose certification because sprinkling is important to put fire out and move people in the safest way. Sprinkling and fire departments, they don't care about equipment. They don't care about buildings. They make more damage than fire. But whole objective is to move people out. Insurance will pay for everything, you understand? But because we are narrow-minded, we don't understand, and I'm saying, if you have, let's say, a hospital, interstitial floor, where all the equipment is located, entire floor, you don't have to provide sprinkler protection. Only you put piece of equipment in a service room, now you have to do it. Why? So here's an example, and you'll see. It was Rule 26008. It doesn't exist anymore. In a new code, you don't have it. Another example, actually, Stantec in Vancouver did a project in Birmingham. And one of leaders there calls me this Ark. We had 42-story building in Birmingham, residential. And we didn't put receptacles in a stairway. He said, code requires. So what do we do? I said, you know what, I'll make a proposal. Why? Because you don't put anything in a stairway. Because any time you start putting anything in a stairway, people will tumble, because when people move out, like a stampede during fire, you cannot create any cord-connected appliances in a stairway. The only thing in a stairway, you have a speaker for voice communication system and standby system. That's it. That's, of course, emergency lighting and normal lighting. But you don't put equipment in a stairway. You put it on a floor area. Because stairway only for people to get out. Second argument I made, if we are so committed to receptacles, why are we only doing it in residential buildings? What about office buildings? What about commercial buildings? What about assembly occupancy? And we have why, and nobody could answer me. So I contacted building code committees, and they said, yeah, we have to remove it. It was completely stupid. So this time, you'll see receptacles are not required. Problem for this Stantec design, because they had to do change order, because they actually told Burma, the chief of the Conductors, talked to Ark, and they were really upset. I said, well, Ark, why are you involved? They're asking me, I know the proposal was sent, and I said it was accepted, but we still enforcing 2018 code.
Yes.
Or 2015, I forgot.
Building code,
Electrical.
Yes.
No. I forgot what time it was. So they have to negotiate. But inspectors must enforce what's in the code. But what we're doing, we're explaining why codes are changing. So you can see improvements of safety, clarification of certain requirements, correlation with product standards or with building codes, but most important, mistakes were made. We have to correct them. Or word is written in such a way nobody understands. Recently, I had somebody call me, inspector, they installed Raceway in a swimming pool on a ceiling. Inspector looked at rule 6806.068 and said, no, you cannot install because you cannot have raceways or wiring over pools. I said, this was written for overhead wiring. When pool is outdoor, you've got millions of pools in North America, literally millions, in a building where you have to run a raceway under ceiling for lighting. So we had to do special permissions. So,
okay.
But
that's called variance?
Yeah.
Okay.
It's called variance alternative solution. In electrical code rule 2030, it's called special permission. You can apply for special permission. So I just want to make sure everyone sees me. Okay. So those are the reasons for code changes. So
yeah, go ahead.
Is it okay? Because I like to move, but it doesn't really matter.
Yeah.
So, and as I explained, every 3 years, CSA issues a new code book, because this new code book is a compilation of all those proposals.
You want me to hit them to show?
Yeah, I'll do it, except I have to do passport. That's fine. So every 3 years, we publish code book.
But building code updated every 6 years. Right?
Building code, I just spoke to my counterpart, manager of regulatory affairs for building code. And I said, you're supposed to bring new building code in 2000. He said, no, we're making 2021. I said, but now it's 2022. Where is the building code? He said, it will be in spring. So they're waiting.
Okay.
So, but there is no rule. We actually correlate our code with US NEC. And I represent CSA on National Electrical Code Committee, so we do correlation. So, I don't know, it's not a code. So, and as a result, CSA publishes code, but this code is a result of changes. So, as I said, subcommittee approves. Then subcommittee writes recommendation, it goes to public review. Everyone who has access and it's accessible can make comments. And let's say somebody makes comment, no, this rule is not appropriate. It creates problems. Your subcommittee never paid attention, that creates inconsistency with other rules. Public review comments comes to subcommittee, and I'm chairing 4 subcommittees. I'm chairing section 8, I'm vice chair of section 4, I'm chairing section 24, 46, and I'm vice chair of section 32, and I'm member of another subcommittee. So in a subcommittee. So chair of subcommittee looks at it. He says, you know what? Arguments in public review are persuasive. We have to take it back and clean it. And when we'll clean it up and we interpret, substantiate public review comments, so what's happening? We send it to main committee, big committee, which operates not by consensus, but by voting. It's like a Senate. You're in US Senate, you have to reach 60 votes. It's called filibuster. In Canadian Electrical Code, it says 60%. So if we've got 42 members, so you can see 25, 27 members must vote for it. So you can see subcommittee review, public review, technical committee review, and then regulatory review. All provincial chief electrical inspectors and 3 municipal for those cities which are chartered, like Winnipeg, Vancouver, now Calgary. They also on technical committee. And they have to say, no, we cannot accept this proposal from a regulatory perspective, not from technical. Technical, I may not like it, but majority decided. But from regulatory, for instance, I'll give you an example. Let's say I'll put proposal in section 62. Section 62 deals with heating systems. Some of you remember. And I will say that my, let's say, radiant heat circuit breakers or fuse switches, we tested under condition that conductors will be selected for table 2 or 4. It means Raceway or multi-conductor cable, and temperature of termination cannot exceed 75 degrees. Then they tell us, but don't worry, this 75 degrees only applies for only 1.2 meters from termination. After that, we never test, so we don't care. So it means if you have, let's say, a conductor installed, let me, if you have a conductor installed, and you can see we've got rules here, different rules which we reference. And let's say all ampacity tables are based on 90 degrees C. And normally, what's the temperature here? 20, 21, 22. We don't have very hot rooms. So if service room doesn't have any ventilation, a room is hot, oops, we have to reduce ampacity based on ambient temperature, because the warmer temperature, electrons become more chaotic, resistance increases. So we have to upsize conductor. So let's say my temperature, this I'll give you an answer in a second, in a room is 40 degrees. And I selected ampacity for my number 3 conductors based on 75 degree termination, which is what? How many amps? Which is what? 100 amps, right? Mark it down. Okay? But now I install this conductor, this in this room. This is my service room. Even bigger, but this is good enough. And panel board is only right there. So 75 degree applies only to up to 1.2 meters from termination point. So now I'm saying, conductor in this room subjected to much higher temperature. Tell me, what correction factor should I apply to my conductor? Anyone? At least give it a try. Tell me, temperature is 40 degrees, yeah.
75 degree clock, so you have a 0.88.
88, everyone agrees?
91 is 88 only compared.
So what are you telling me?
In the room, I think it's a 0.91.
You are amazing.
Right.
I'm impressed. And this exactly answer to your question, because look, we already bought 90-degree conductor. Number 3. This conductor already has 115 amp assigned ampacity. But we said, no, because we're terminating it as the weakest point. We now changing our assigned ampacity to 100 amps. Now you want me to apply 0.88 to perfectly 90-degree rated conductor. My conductor has actual insulation 90 degrees. So I'm using 0.91 because your bloody reduction applies only to 1.2 meters of termination. Why conductors of the entire room has to suffer? Do you follow? So it's a reason we only apply a termination. If you look at my article on transition from underground to above ground for termination, so you can select same conductor as per table D8 to D11. But when it comes out like a snake from below ground for termination, we have to use same conductor size and see what it will be carrying in accordance with table 2 or 4. You understand? And apply in table 2 or 4 ampacity based on 75 degrees, because it's exactly where we're terminating. But you might have 300, 500 feet underground cable. Look at, you've got charging station and you're running underground. You can use 90-degree conductor.
So that means you can change, right?
Conductor?
Yeah.
No, you don't have to change. What you do, you always have to take lower ampacity. Lower. So if ampacity, let's say, above ground is lower than below ground, so for entire conductor, your ampacity will be small. Same as we said, if 75-degree ampacity applies only to 1.2 meters, but your cable is 1,000 feet, we're still using ampacity based on 75-degree column because it's the smallest link. But unless you want to splice it before termination, I want to make sure it's understood.
Confused.
Okay, take a look. So you have this long conductor, and this conductor is terminated from panel board, which is right there, to a motor, which is right here. Okay, and my, let's say, because it's a motor, let's say I have 100 amp motor. What will be conductor size? So you can say, oh, it's unfair. You should ask, what must be ampacity of conductor? Hey, I can tell you, we go to section 28. And section 28 says that ampacity of conductor must be not smaller than how?
1.1.5.
Good. You got excellent design team. 1.25. So it means ampacity of conductor must be not smaller than 125 amps. Okay, 125. So far so good. Agreed? And you selected, let's say, tech cable or AC90 BS. Okay, so I'm saying, let me take a look. I'm going back to table 2. I'm going to table 2, and I'm saying, I've got conductors, which a 90-degree conductor, but I need 100 conductor to carry not less than 125 amp. Could you select conductor for me, please?
Number 2.
What?
Number 2.
Number 2? Why?
Because you choose use a 75-degree.
Take a look.
What is it called?
We are connecting this conductor between a circuit breaker, which is marked for 75 degree, and a motor, which may not have any marking. So we have to, by default, use 75 degree. But we still have 90 degree conductor. So we take a 90 degree conductor, but which temperature column we using? 75 degree, because our weakest point, smallest point, up to 1.2 meters from termination, actually determines ampacity of conductor. It's like you're running together with somebody, and you have to run as a team. And he can do a 5-minute mile, and I hardly can do 10. But we're running together, so our speed will be based on me, because I'm the slowest person. So, do you follow? So, you have 90 degree conductor, you selected for 100 amp motor, and you said conductor must have ampacity not smaller than 125 amps. So which size do you have to select?
In this case, based on 75 degree, like answer is number 1.
Exactly. But it's a reason why I'm saying, because you have to take into account all conditions. First condition, your load, 100 amps. It's a motor rating. Second, a rule in section 28, ampacity of conductors must be not smaller than 125%. Make sense? So you're saying, I cannot select conductor with ampacity less than 125%. You can say, I can select number 2 because I have 90 degree conductor and ampacity is 130. And then you say, this conductor not just another pretty face. It's a conductor which is means for connecting between one piece of equipment and another. And each piece of equipment has marking 75 degrees. So I have to take beautiful 90 degree conductor and reduce ampacity of this conductor based on 75 degrees. So which conductor size will allow me to use my 125 amps? 1. And it's exactly what I said. Why? Because weakest link is 1.2 meters. You can have huge long conductor, but weakest link determines. So because we're using conductors not just for fun, but for termination, if we would use it to skip, that's fine. But we're using it for termination, so we are applying these requirements. Okay, I use number 1 conductor. Everyone agrees? Now, temperature in my room, in this room, 40 degrees. What correction factor should I use?
You just said is use 90 degree for correction.
Yeah, so what do I use?
0.91.
Exactly. Do you follow? Everyone is clear on this. Because she will test you. I'm authorizing you to test me. No, but what? It's so important for me to understand that you got it. Because, okay, next condition. Now, George comes to me, or George says, hey, I got one raceway. Can I put 2 circuits in my raceway? I don't have more raceways. Come on, same panel board, and I will run to another splitter and then go to. Can I put more than 1 circuit in a raceway? Come on, people, talk to me. What do you think? Of course I can. I'm not violating any rules, but if I have more than 3 circuit conductors, we don't count in neutral, because neutral doesn't carry load, that carries unbalanced current, unless it is single phase. So hot and neutral carries the same current. So now I've got 6 conductors. So I have to take 125 amps in from table 2, multiply by not 120, 130 amps, because can you see for number 1 conductor, for my 125 amp minimum allowed ampacity. Do a little exercise. Now I've got for 75 degree, 130 amp. So far so good. But now we realized that we are running this installation in ambient 40 degrees. So number one conductor will have what ampacity? Come on. Pull out your calculators. And I'll pull mine. I have to check.
What's the factor we're going to use? 0.88, 0.91? Yeah, so 0.91 multiplied by 130.
So what?
180.
Perfect. 118.3. So what does it tell me? So what do I have to do? Increase. And what conductor would I have to select?
Wow.
Take a look. Next one will be 1 watt, right? And 1 watt in this case will be not 150, but I have to take 150 multiplied to 0.91, and I'm saying now it's 136. Still good. But now George asked me to run 2 circuits in a Raceway. And I know that I selected with all those incremental changes. So my perfectly 90-degree conductor, which had 15 amps right here. I'm sorry, we did with what? Yeah, it doesn't work, so we have to select not this one, but we have to select this one, which is number 1, and then multiplying by 0.91, we realized we need this one because it will be now 136 something I just said, 136.5. Do you follow me? But now I have to go to table 5C. Oh, come on, where is my table 5C? What's happening? I made a mistake. Let me go back to rule 404. Now I have to go to table 5C. And 5C says, if I have 6 conductors in one raceway, by all means, do it. But now I have to reduce ampacity. It means increase size, because for this ampacity, size is not sufficient. And now we have to again take our 136.5, whatever, multiply by 0.8. So you can see how many, and then George comes and says, look, my run is 400 feet. I have to check voltage drop. You may have to bring conductor size up again. So what you do, you look at all necessary conditions. First condition is connected load, then selection of conductors per table, then restrictions on termination temperature. Then you go to correction factors based on ambient temperature or something else. It's exactly how we design. You can see, and you keep juggling all the time, because if you don't do that, you'll be in trouble. So we'll overload circuits. So it's a reason, and take a look. And I started with a little exercise, change in definition, ampacity. So ampacity is actually temperature of conductor or its insulation. And I will do it all the time today. Why? Because I want to connect what we changed to practical reality. And please stay with me. I don't want to see you looking at, if you have to look because of, but you will miss opportunity for our discussion, because if you're looking at your phones, you're not communicating. Only very, very few people can actually look at phone and listen what's happening. But I don't want to waste your time. So please concentrate and ask me questions.
Okay, question. So right now, because the material price increased a lot, right? So if a longer distance, they use the splice for the shorter 1.2 meter.
Yeah,
The big cable, the rest that can be used the smaller cable. They'll save a lot of
of
money.
course. And
Yeah.
this, as you said, this could be done only if you run single conductor cables in a cable tray. Because single conductor cables for the same size have much higher ampacity. And you can run in a cable tray, in a free air. You can do, when you come right to your panel board, a little bit outside of 1.2 meters, put a splitter, terminate your conductors, and then increase size, and conductors in raceways will come as done. But in normal, traditional, our day-to-day installation, it's too expensive. Too expensive. And also, anytime you do termination or splicing, you create extra heat point. So it's not good. But you're not, and you have to, as a contractor, you have to understand, am I winning? Am I getting benefits? Because I actually don't mind this 75-degree forcing us to upsize conductors. You know why? Because of voltage drop. You never know. It's much better to increase conductor size because of voltage. So far, so good?
Yeah, so I just want to talk to Mark. It's almost an hour. Are you okay?
I can
Oh,
go
we can
until midnight.
I know,
You-
but you want to take a break, like
It's
5
up
or
to
10
you.
minutes break?
You do this stuff.
What do you think about?
Are you
it?
okay
Does it need
so
a
far?
break, 5 or 10 minutes break, or? That's better? Okay. No, so we almost have an hour talking, so maybe
Okay.
take 10
No, but-
minutes break.
yeah, by all means, do whatever you
Yeah.
you deal with logistics. But folks, as I said, what is objective of our discussion? For you to understand and be able to find necessary places. Hey, we remember this crazy Ark came and he talked to us, and I remember now I understand why we're doing it. Because just memorize its points. Okay? So, okay, let's do a little break.
Okay.
Do you want 10 or 5 minutes?
5. Say
5.
then we
Let's
got
do
a 10.
5. I just hate to waste time.
Yeah.
Now you can look at your phones.
Oh, dear Lord.
I don't need.
Oh,
Yeah, thank you so much.
oh, I see. We can get some.
No, don't worry.
Okay. 对你把那个那什么，要让它永远不那个变成屏保就好。刚才可能是变成屏保了，就断了还是怎么着？
但是它这个是
啊，
这个已经是内味了，
哦，
对啊，
哦。So how do you feel? Oh, yeah.
接它的，但是如果这个是允许的话，那就是可以。
This
technical conference.
Yeah, they asked me
to be there as
to help me also.
will be done by you.
You can see I'm doing and then I'm helping this guy with this subject.
Okay.
So he's asking if I'll come face to face or I'm easy because
Referral.
Yeah, I prefer face-to-face.
Oh, yeah, I like that
like
too.
face-to-face.
I like to, yeah,
Because you can see different things.
exactly.
就是我觉得从这两个理解，就是我们要问这个逻辑，
She
做这样的事
works
情，
for
我可以这件事情是你说啊不符合规范，是符合规范的，我就是1.2米，但是就1.2米，而且我有他不够服务，他多的就是 Stantec inspector 说的只是那个 discounted switch，有一点儿是不是，但是他那个怎么回事？
I'll let them know. I'll let them know.
还有这个问题，因为你 break 那个不一定是根据的是 rating 来常规的，就是你超过80，这是很漂亮的。
So far, so good.
超过80规定，我说你是100公人的，是基本上
Maybe you can.
可能会点。
为什么会跳水？
Of course.
One hour program.
Whatever you need.
我说了，那就
Everything. And again, so
So, I'm planning maybe we can go to Saturday. I don't know why, because I have such a plan. But so far, went through the code actually. You know, we have done many projects, so people, my research engineer, sometimes they are confused. We have code consultant, right? They will say you need to do this. We mainly focus on electrical stuff. The people most time don't focus on like the fire protection, you know, it's FT4, FT6, it's combustible, you know.
okay,
Yeah.
I will give you a checklist, which I developed for
Okay.
different cores using my checklist.
Okay.
And it gives you everything, all the electrically connected life safety systems,
Okay.
fire system, hold open devices, electromagnetic walls, smoke controls,
Yeah.
dampers, fire alarm systems, single stage, double stage, voice communication,
Yeah.
signal to fire,
Yeah.
zoning, emergency lighting, exit signs,
Yeah.
so fire alarms, so emergency generators,
Yeah.
U654. So
Well, that would be good if you're interested in that checklist, I'll check then maybe more sidewalks.
yeah, but we not immediately we can do it later.
No. Whenever both.
Yeah, that's what you do. I'll send you all today or tomorrow checklist. And
No,
then-
no really rush.
No, because I was doing it. It's my nature because otherwise I forget.
Me too, yeah. So many things to do.
Well,
If you want to go to
yeah,
work,
for sure.
I don't know, I can never go to the either. Okay.
There's one right here. It's like a handicap. Yeah, all right here. Okay. It's from.
Okay, yeah.
Good. Billy. Yes. I just got
Okay, you guys feel free to ask questions. On each side. Okay. Can you understand what he was talking about? I mean, Ark has some accent, so, his own style, yeah, so maybe.
I'm just, it's a little easier for me to have visuals, so I think when I get back, I think the book will find
Uh,
this visual.
Well, we got
People expensive life.
casting operator on the.
这个有关这个没有实力干的那种。这个当我们3个学员。
Right now is 270.
变蓝是啥？所以你选的时候，你即使选的这个路，
你看你这个要是搭我还是3个学员。 一个搭个流程。行 ，OK， 这样，好，拜拜。
OK，
我这个一定要这是水。
我跟着说。
对对，是这样，对。哎呀，
哎，你好，没事没事。可能你们第一次听二个这个，跟他接触的这个意思。他一会儿我给大家讲一个故事，他帮我很大，就是10年前我有一个项目，他一出面，大家都知道，所以他不只是在加拿大，他经常就是他代表加拿大作为一个加拿大Renovation Approach 旗帜然后他经常和欧洲的合作。还是为I'm sure you don't need a water.
Yeah, I'll get lots of water.
This is okay, or I get some water for you.
Do we have any water?
Okay, I'll ask them to get some.
Just from. 上峰先来那个 Flammable 那个碳化死方那里去。
你说 electrical 谁做的？
对，
我们那边医生，医生，认识医生的你打交道 ，Blake 医生都是
因为还有另外一个 Granville 上面有一个碳化水也是。
对，那个也是谁 Hungry 那个也是医生，
也是医生。
对，你可以医生为了医生在没在等会儿医生来了，跟他说我打电话。对，哦，那个。着急的起步，这个我说的，如果价格提高一点的话，可能管理的不擅长，有一些是别人认识的。
啊，这样。
你演那个多伦多他那个 front 在问那个巴尔拉是不是我们这个
2月初。
那也是 yesterday 还有抓紧点吧。
行，没问题。我看建筑让你发现他 review， 我觉得你可以先把昨天那个给他打过去，因为我们只是 mechanical audination 没做完。
哦。
他如果有 comment 的话，我们还可以接着再打 review。
哦 ，OK。那我今天给他发过去。要不错的。Okay, yeah, I think we can start.
Can we continue? Okay, so let's move, folks. I can spend so much time on every definition. I just want you to know that certain definitions have been changed. Some editorial, some cosmetic, some, it's not a big deal. But you can see what is good, George, in this document. You can see any new stuff. Can you see it's underlined?
Yeah.
Anything old, deleted. So you immediately will see, because in a code, new code, you will never know what happened. But here you see what was new, what was. So I'm going, oh, this is interesting. This was a result of climate change adaptation. So we were asked to help to deal, and I was very reluctant. I said, look, it's a safety code. We don't deal with climate adaptations. They said, okay, could you at least acknowledge that if there is a flood elevation by municipality, like in Richmond, for instance. So I said, fine. So we wrote definition, flood elevation, flood hazard zone. And what we did, we actually said, hey, conditional to building code or applicable local legislations. If local legislation doesn't have anything, we don't care. But reason we wrote this stuff, because if, let's say, you're doing project for Richmond or Denver.
Even we did this report.
Exactly. So yeah, same city of Vancouver, because do you know where Falls Creek there is, or South Vancouver, Fraser River floods. So what you have to do, you have to keep your service equipment above flood level.
Yeah.
So we put these definitions, and we change rule in section 6 to make this requirement. This is important. So we traditionally used to do 751. But now IEC and NEC, National Electrical Code, started to do 1000. And for DC, whatever is a new code, 1060, but actually write it down, 1500 volt. Why? Because we made so many changes. So you'll see in a new code, it will be, so DC, because we've got so many charging systems for superchargers for Tesla. They're 1200 volt. So up to 1500 volt, it's still low voltage. But AC 1000 volt, this is marked down. Okay. And again, you remember I talked, if you have something subjected to flood, ingress of water, oops, it must be evaluated, subject to testing. You cannot, as we talked about, copper conductor for ground, it's nothing, but piece of equipment has to be tested. Rebuilt equipment, new rule, read it. This is important for you. So you can say, what do I know about seismic? Nothing. But you guys know in your design, you have to take responsibility when you do EGBC checklist and letter of assurance. You have to know seismic. So what you do, you hire a seismic engineer, let them do it. But it's your responsibility because you're responsible for design of electrical equipment. Mechanical consultant knows nothing about seismic, but mechanical consultant's responsibility to hire seismic engineer, but we put it in the code. So you can see.
Question for this part, for
Yeah.
the seismic, for all, apart from all the Canada, all the certain area.
No, because it is a national code. But what it says, take a look, in compliance with National Building Code of Canada. So if a building code says, and building code has all bunch of graphs for certain area. So of course mind you, in Ontario, recently it was earthquake in Quebec. Earthquake was recently. I was at, I forget, Charleroi. It's about 300 kilometers from Ottawa. It's close to New Brunswick. And we had earthquake. So, but it's not up to us. Let's say you're leading by two experts and they will talk to architects. Architects will say, hey, do we have to seismic assessment? In BC usually. But,
So actually, this is based on the structure. Structure has a calculation. There is set in that location, they use seismic listening. Even in the Ontario, some area, yes.
Yeah, I agree. But it's like, take a look. We have requirement in a standard for fire stops. Oh, thanks. What do you know about fire stops? Tell me.
Urban fire.
Okay, good enough. Ask me, what do I know about fire stops? Ask me.
Okay.
Not much. I know, of course, I know, I did, but essentially, I'm a fire protection guy. But I know Article 3.192, but what it says, building code says, hey, you drill the hole. You have to make sure that no gaps. And if you drill holes for your electrical cable or electrical raceway, it is your bloody responsibility to ensure fire stoppers down. You're doing renovation or you clean. It's your responsibility to bring mop, and because owners are saying, what the hell are you doing? You learn so much less. So, but what do we know about fire stop? Not much. What do we know if fire stop meets the requirement? Let sub 3, who is hired by a contractor, to give certificate. It means it has F or T rating. So, but it's still in the building code. What do we know about flame spray? What do we know about building construction? Of course, we learn more and more. But in the code, because we deal with conductors, we have to know what conductors to select. If it is building of non-combustible construction, it must be FT4. If we have planning, it must be FT6. So it's our responsibility, but it's a building code requirement. Appendix B explains, so it's the reason why we have to deal with it. So building code has so many funny things. What about, we talked about protection of conductors against exposure to fire. We don't know much, it's a building code. It's Article 2710 of the building. And yet, we have to think how to protect. Are we using circuit integrity cable complying to ULC S139, or are we putting conductor in a fire-rated space? So it's part of your design. We have the luxury. Or fire rating of service room. We have to know that. Okay. This I'm not spending time. It's all okay. New requirement for industrial or commercial structure. If you have transfer equipment for connection to at least one receptacle, must be provided that's supplied by a circuit which is connected to or capable of being connected to alternate power supply. Why? Because what happened in Ontario, they had a huge industrial, like a building, metal building, mobile, and output was high voltage. Input was 120, and we had step-up transformers, and two cleaners came in, and they connected their vacuum cleaner. But transfer switch didn't have interlocks, and actually there was no power, no electric power, because it was absolutely, no, they actually brought a portable generator because there is no power and no receptacles. They wanted, but when they connected portable generator through transfer switch, through transformer, 25 kV came and hit them. And it was coroner request. I think it was in Cornwall somewhere, yeah. So, and two people died. So now they're saying, oh, bring for this structure receptacle, so which will be connected to alternate power. So, and if you look at a rule in section 36, we beefed up a rule in rule 36 to 14. I'll show you later. But you can see, because experience teaches us, so we have to provide new rules. But again, no reason for me to even go through it. You know exactly, it was a subject submitted, and everything what is underlined here. Auxiliary gutters, we explained that we don't apply to gutters which contain less than 30 conductor or inside of electrical equipment for termination, because inspectors came up and they said, oh, we have to apply correction factors because we've got 3 conductors, 4 conductors per phase. And we said, no, you're already terminating inside of equipment. We don't apply those correction factors because all conductors, cables were spaced, and at termination, they're converging together. So inside of equipment, we don't care because amount of heat is irrelevant. We already, our objective is to ensure that temperature termination doesn't exceed marking, which is 75 or whatever is marked. Or manufacturers decided to get rid of gray covering, so it's only white. So you can see. Section 6. See, I told you, for political correct, we don't put equipment below flood elevations. What is flood elevation? We've got definition. Let building officials deal with it. So you can see how it all.
So normally, city will give you the flood elevation.
So yeah, so what happens? Let's say you're a fire responder. You come to a building and there is a fire, and service equipment is in a basement. So what do? Swing to your service equipment. You will be electrocuted. It's a reason why a new rule was added. You understand? So immediately you catch it. Why? Because they want to kill power. They have to be safe. Cosmetic, joints and splices. It's exactly, John, we're talking about you join, you splice. Splices are allowed, but so people have to. We put lug, clamp, little things. Section 8. We clarified. So what you do if you have heating and air conditioning loads working in a building, and you can guarantee that they will not work together. So they're interlocked properly. So which load do you take?
So we want to interlock to make sure heating and cooling are not running at
At the same time.
So this interlock is mandatory right now.
Mhm.
This interlock right now is mandatory as per.
No, a rule, it was just clarification. Because, see, before it used to say, will not be used simultaneously.
Okay.
But now we said, no. People will say, what does it mean simultaneously? Somebody says, no, I will not do it. You have no control. If your system is set up, building management system, somebody wants heat, somebody wants cool. So we wrote, no interlock when interlocks are installed. So at least it gives your designer more ammunition.
Okay, we have done many federal government projects, and they really emphasize on energy efficiency. So they don't want the building system has cooling and heating equipment or system running simultaneously. But this can be implemented either through software interlock
Yeah.
or hardware.
Yeah.
Software is
Yeah,
more feasible.
absolutely.
Yeah.
What you do, and this is very relevant point you brought, because nobody says it must be interlocked by transfer switches. Means interlock means controlled. You know absolutely that under no condition, and this is what it means. So
But this is not 100% feasible. You can do that maybe for 80, 90%, sometime for complicated building. Some tenants need heating, for example, if one room very close to the boiler room, it will be very hot, right? If one room close to exit wall and it doesn't have a very good design mechanical system, it could be very cold.
yeah,
They
I
need
agree.
heating, and the other room, they need cooling. So even during summer or winter time, you can't avoid 100% no heating or cooling running at the same time. So this
Yeah,
is very
this-
complicated.
This is done only for your load calculation. So when you calculate load, you've got heating and cooling. In my house, I've got thermostat, and I can put off heat or cooling. That's it. So it's interlocked by thermostat, or one or another. So, but I agree, in commercial areas, sometimes somebody wants heating, cooling. So what you do, you become accountable for your load calculations. It's your responsibility. So if you know that two loads will not work at the same time, take larger. That's it.
It's not only for reference, right?
Hmm?
Only for reference and not mandatory, you have to follow this part. This rule. I mean, this rule for demand factor is only for reference, when the calculation,
Reference.
not for mandatory.
Is it mandatory?
No, it is. What it is, use any demand factor rule allows you to reduce your calculated load. To reduce. So when you do calculated load,
Understand, but the situation is not different. If, for example, George said for the mechanical, some heat and load, they have 4 pipe and 2 pipe. If a 4 pipe, the heating and cooling, they can both go together.
if they can, see,
Yeah.
it's the reason why words were changed. Now it says interlocked. So your client has to demonstrate that loads will be interlocked under no condition.
My understanding is we have to try our best to
Situation.
put this requirement in our design, whether to what extent this interlock can be achieved. It's a practical.
So actually for the based on now the long-term care, non-thermical, all the outload, your cooling and heating working together.
I know.
So some loads are interlocked, physically interlocked, or by software, or by physical. It's like a transfer switch. I'm feeding or one load or another, and it helps you because you can reduce your calculated load. So when we deal with demand factors, this is important rule because it deals with load calculations. Okay.
So most time when we did the load calculation, we choose whichever is high, is higher.
Yeah, the view is high.
Either cooling load or heating load. Normally we don't calculate both heating and cooling load together. That's the point.
Can we move?
Yeah.
Okay. Again, we cleaned up this rule for you. It's important, but it made it very simple. So it says panel boards in dwelling units shall have at least 4 additional spaces left for future overcurrent devices, with provision for 2-pole device at time of original installation. If you have dwelling unit in apartment building, not a single house, simple, it tells you, must have at least 2 additional spaces left for future overcurrent devices, with provision for 2 poles at time of original installation. Why? Because it's only in dwelling units. You never know what do you need. Of course, in apartment building, you have less opportunity to tinker. But in a single house, today I don't have air conditioning. Tomorrow I want air conditioning. Oh, I want swimming pool. Do you know? Oh, I want 2 electric vehicles. Check your loads. You understand? But this is exactly what it says.
Another question for you. So when you said 4 additional space is a single, one pole space, right?
For 2-pole breakers.
It means for 4 additional is for 4 single or the 4 2-pole device.
Right.
The 4 device.
Yeah. Take
That
a look.
means 8.
At
8
least,
like a
yeah,
single
4
space.
additional spaces with provision for 2 pole devices.
That means 8.
Exactly.
8 space. Okay.
You know, there are 3 types of mathematicians. Those who can count and those who can't. Anyway. Okay, it tells you how do you determine area. So you don't determine area if it is crawl space, but if it is a basement, you have to take it into account.
Oh, okay.
Yeah, because 1.8 meters in a building code, it's a boundary condition.
Right.
See, basement cannot be less than 1.8 meters, but crawl space could be 3 feet. You crawl. A basement must be like you can walk. You're probably more than 1.8. So, okay. Oh, this is interesting. So I wrote an article many years ago, 5 years ago. And people started to install quadruplex receptacles. Right now, if you go to Rule 8304, it says 12 outlets. 12 outlets, it means 12 duplex receptacles.
12 means 6 duplex. Oh,
Duplex.
Duplex,
But people were confused because people ask the same question. 12 outlets, it means
6 duplex.
what is it? Is this outlet?
Yes.
This is one outlet. It has 2 yokes, but it is one outlet. And I love your question because it's exactly people were confused. And traditionally, we said 1 duplex receptacle is 1 outlet, and 1 duplex receptacle considered to be 1 outlet. Why? For purpose of calculation, because you take 12 of them, 12 amps, and you will protect them by what circuit breaker? 15 amp, because your load supposed to be not more than 80%, right? because circuit breaker is not marked for 100% continuous operation. But in reality, you plug something, a computer, it's only 40 watt, but if you plug, let's say, coffee maker or toaster with 4 pieces of bread, it will take 15 amps. So, but in practical way, you will never plug every bloody receptacle. It's impossible. Even if you want, it's impracticable. So it's a reason why. But take a look with now. It's interesting. So 12 for 15 amp circuit, which is marked for 80%. And as we just said, each one is 1 amp. 12 of them, 12 amps. So not more than 12 if circuit breaker marked 80%. If circuit breaker marked 100%, which you will never find, 15 amp circuit breaker never marked for 100%, hey, you can do 15. Now, if you have 20 amp T-slot receptacles, you can put 16, because 16 multiplied by 1.25 will give you 20 amps circuit breaker at 80%. Well, you can plug 20 if circuit breaker marked 100%. Wow! Now we answer George's questions. When receptacles used as an outlet, here's outlet, here is outlet with 2 yokes. It's a duplex receptacle. It shall be considered 1 outlet per duplex receptacle. So 12. 1.5 if you have triplex receptacle. Sometimes it happens. And 2 outlets per quad. So if you have quad receptacles, you cannot do more than 6.
Yeah.
And so now we've clarified the rule before. And again, not exceed maximum number permitted in sub-rule 1. And we explain, depending on marking and circuit breaker. Folks, is it okay? Everyone is clear?
In normal, typical practice, design practice, we assign 4, maximum 4 or 5, normally 4, less than 4 receptacle, duplicator receptacle
Yeah.
per circuit.
Yeah.
So it's a lower, it's
Yeah,
how to say?
it's a good design
Yeah.
practice.
Yeah.
But it's allowed because when this one doesn't talk about outlet. Outlet could be outlet box for lighting fixture, smoke alarm. So it's all outlet. Okay. Section 10. Let me spend a few minutes with section 10 because what does section 10 deal with? What does it deal with? And bonding. What do we ground? Any idea?
Neutral.
What?
Neutral.
So it means a neutral is part of what?
Within system.
System. So essentially, we grounding system. So if system is solidly grounded, we have to take neutral point and connect to ground. Normally, where is system originated? Where?
Generator.
Beautiful. In general, system, where is it originated?
Station.
Which, in fact, where?
Or stations.
DC hydrant
Yeah.
gives us a system. DC hydrant could have a transformer, primary 12 kV or 25 kV, secondary 600, or 122A, or 277/48. So we take in secondary of DC hydrant transformer, and hydra already ground system. but we don't know what they do. They may mislead us, but they tell you, we give you three-phase four-wire system. We know it's a solidly grounded system, and we ask. So when we bring this three-phase four-wire system conductors to the service, we have to re-establish a single point of grounding because we can't rely on this. We call it single point of grounding, but it is a hypocrisy because single point of grounding is a place where system originated. As George said, generator, because it's our generator. We only ground at generator unless generator is connected with three-pole transfer switch, the neutral solidly bolted inside the transfer switch and connected to a single point of grounding at main service. Do you follow me? Everything, yeah? Or do you want me to write it down? Are you okay, or you have questions? Can you visualize it? I can.
I can.
I know. I can feel some. I'm looking at ice, and I want to make sure it's clear. Okay. So, and single point of grounding is established at the service, and we are grounding system. And conductor, which is used for this grounding, as you said, neutral conductor. Because neutral, it is a grounded system conductor or grounded service conductor. It is grounded already at utility. We bring it to the service, and what do? We do three things. We have three lugs in a service compartment. One lug for terminating neutral and connection to a neutral bus at distribution portion. Second lug for connecting to the enclosure, and then bonding bus will be in a distribution compartment. We call it, or bonding screw is in, or bonding jumper. Do you follow me? And finally, another, so I said one for neutral, one for, and finally, another lug comes to this neutral conductor and goes where? To ground electrode. So we are regrounding system at our service. We are not connecting grounding electrode to bonding bus. No. We're connecting to the neutral. And what's the size of grounding conductor?
At least six feet.
Minimum number 6. Why? I'll tell you why. Will grounding conductor carry a fault current?
It's like it's 30 ohms. It's like an ohm. We could I forgot the 50 or the.
Oh, okay. 20 ohm, but it doesn't really matter. But key is, what does grounding conductor do between neutral and ground electrode? It creates equipotential plane with a neutral, which is already grounded at DC hydrant. We reassure it. It's like a safety net. Because if there is a fault current, it will go through the bonding conductor, which is connected to metal enclosure of every piece of electrical equipment, exposed metal enclosure. If it's hidden, we don't care. But enclosure, which may become energized by accident. And we're taking bonding conductor and carrying it back through a whole bunch of intermediate distribution tunnel boards back to the main bonding bus in the service equipment. And this main bonding bus is connected by bonding jumper to neutral, which came. So, if there is a fault, let's say I'm a piece of equipment and hot touches my enclosure, somebody touches me. That's it. could be electrocuted. In this case, person will not be electrocuted because current goes through bonding conductor, which goes back to the big bonding bus, and then goes to neutral. And from neutral, where does it go?
It's all ground.
Will it?
No,
Let me just.
to the ground. Then you need to start.
What's going on? Okay, so take a look. Look at this rule, 10 to 6. AC system, it's fine, must be grounded, solidly grounded. If maximum voltage to ground doesn't exceed 150 volts. Give me example of standard voltage doesn't exceed 150 volts. 120 standard voltage. Okay, so if you have 120 to 8, 120 to 40, system must be grounded because we touching those receptacles and this neutral at 120 volt will be exposed. When do we need neutral in 600 volt? When we have single phase 347 light volt lighting, then we have three phase 4 wire, and we're using solidly grounded system. So it says not exceed 150 or system incorporates neutral conductor. BC Hydra gave you neutral conductor which comes from their solidly grounded system. So let me take you through something else. We'll come back to this one. Now, take a look at this rule. Grounded conductor of solidly grounded system. How do we call this grounded conductor? Of solidly grounded system. How do we call it? We, traditionally, you have BC Hydra solidly grounded system. And grounded conductor of the system, it will be what? How do we call it? First letter N. Second letter E. Neutral. Neutral. It's majority of times. Only if they give a solidly grounded system, but we don't need neutral, then this conductor will be simply bonding conductor. I'll show you in a second. Take a look. Grounding conductor of solidly grounded 210 system supplied by BC Hydra, by supply authority, must be connected to grounding conductor only at one point at consumer service and have minimum size specified for a bonding conductor. Wow, it means that conductor, grounded conductor between grounded supply at BC Hydra and grounded service must be sized as bonding conductor. So this conductor will carry what? Fault current. Wow. And then it says, hey, if it also serves as a neutral, it must be sized as a neutral as per section 4. So let me supplement this by picture because we started to talk. So here is your typical 120 to 40 service. So you have two options. You brought, it's a triplex overhead. So how many conductors comes from BC Hydra?
3.
2 hots and 1 neutral. It's 120 to 40. It's called single phase 3 wire. Right? So take a look. Neutral comes here, comes to neutral bus. It's a neutral bus. And is grounded, connected to grounding electrode. As I said, neutral comes here and it has 4 lugs. One for connection to neutral bus, second to a grounding conductor, third to a bonding jumper, it means to bonding bus, and finally to another neutral bus, which will be already isolated here. Because we only connecting neutral to enclosure here, only one place. And then you come to service, this is meter based. You bring how many conductors? Here you bring here 3, and here you bring how many? 4, because you have to bring 2 hots, 1 isolated neutral, and 1 bonding conductor. But in majority of cases, you provide grounding right at service. So what you do now, before we never done it, but now we have to, because we have neutral here, it's isolated because there is no means of meter base to connect it to a bonding. So we bring neutral, it's isolated, comes here, here neutral is connected to grounding conductor and to bonding jumper. And then from bonding bus, it goes back and connected to bonding bus inside of meter base. So this conductor, neutral conductor, carries fault current, because if, let me take 3-phase 4-wire system. Here is a BC hydro transformer. Secondary, let's say 347, 600. So this midpoint between all of them, Y connected point, it's connected to ground by BC hydro. And of course, with bonded jumper, it's connected to enclosure of BC hydro transformer. We know that, but we pretend we don't know because we don't know what BC hydro does. So essentially, if we want to have a single point of grounding, we have to ground only at BC hydro. But because we cannot guarantee, we bring neutral here, establish again neutral bus, bring it to grounding conductor, and bring it this neutral back to the distribution, and then bring it to bonding bus. And already from bonding bus, we connect all other enclosures of equipment. So let's say here is the first equipment, and one hot by accident is connected to the enclosure. Look what's happening. Fault current will come here, then will it go next? Tell me. Up, comes here, and from here, where will it go?
Go grounding electrode.
Here or here?
Now go back to the transformer.
Go directly in the entrance for the building.
So I'm getting to your point. I asked, you said number 6, and I said why? You said who knows?
Both, I guess.
So answer is right here. Listen carefully, because these are fundamentals. So why would fault go here? Because fault has to reach, as George said, a source. Only when it reaches source, overcurrent protection closes to circuit protecting this equipment where fault on the supply side of this overcurrent protection will trip. As soon as fault will get back to the source. Now, question for you, boys and girls. What is easier for fault current to go through this beautiful conductor with solid copper between service and supply, or go here and go through rocks, through streams, through water, through clay. We cannot predict it. Impedance will be incomparable. So, as you said, size of this grounding conductor is sufficient to be number 6 because it always creates equipotential plane of reassuring, same what we've done here, we're doing here. Because amount of current will go here, will be minimal, only charging current or leakage current, because impedance of Earth is incomparable with impedance of grounding conductor. It's a reason number 6 is enough, but it has pitfalls. If you have overhead service and you will lose this neutral, grounding fault current will go where? Because it wants to get back to the source. It will go through all those streams like salmon, through all this clay, will try to go through impedance, and eventually it will find a way right here to the neutral of the source. But number 6 could be too small. It's a reason some of you who've been in this business for a while, George, you remember we used to have table 17, and we used to have 3-watt size of grounding conductor. But now, because we're mandating single point of ground, we're saying, if it happens, it's too bad. But essentially, we have to rely on a single point of ground. Is it clear? It's a reason why number 6 is deemed to be sufficient. But I normally tell designers, I would increase a little bit. First of all, from purely physical safety. And second, what if neutral, mind you, if you design underground service, it's not a problem. Problem is overhead service. If you have 120 to 40 triplex. But now, BC Hydro doesn't provide overhead services. They said, no way. Downtown Vancouver.
In every city, I know Vancouver require underground service, but other cities still accept overhead service.
Yeah, because BC Hydro is doing through changes to 25 kV, and but before, look at Vancouver. When I was with the city of Vancouver, hey, we had all those conductors. You can come and do chin-ups. You can put your laundry on high voltage conductors. So what they do, because they used to provide only overhead service. I came to city council, I said, we have to do it underground. They said, we don't need cosmetics. I said, it's not cosmetics, it's safety, it's seismic. But then before Olympics, they said, Ark, we were morons, we didn't listen to you. Because I came in 93 and I wrote a report to council. And one of councilors was still my council. He said, I remember you made a report. Now it cost us 10 times or 20 times as much. And Mott Electric and who else? Hull Electric, they were doing lots of work downtown, making lots of money, putting everything underground because they didn't want foreign delegations to see all this huge forest of overhead poles downtown, particularly east side, because many people wanted to east side take a look what's happening. So is it clear? So we're grounding essentially system and bonding to ground electrical equipment, and bonding conductor carries fault current, and it must be selected based on what? Table 16, a table 16 based on overcurrent protective device. But if it is a service equipment based on ampacity of service equipment, right? Now, why we don't have a bonding conductor between supply and service? Let's say you're a contractor and you're running service from BC Hydro PMT to a building. DC Hydra PMT, it's a demarcation line. You run in service, and it's a 3-phase 4-wire. How many conductors you will put in a raceway? 4. So 3-phase and
neutral.
neutral. What about bonding conductor? No, I just said, because neutral functions as a bonding conductor. Only here, between service and source, neutral functions as a bonding conductor. You remember when I read for you rule 10.2.10, I said this grounded conductor of a system must be sized as bonding conductor unless it functions as a neutral. It's a reason at neutral we don't need bonding conductor, and only here, take a look from here, how many conductors we've got between this one, between this one and this one? 5. We've got 3-phase in neutral, it's a feeder conductor or circuit conductor, and safety net bonding conductor, which is not a circuit conductor. It normally doesn't carry anything. It stays idle until there is a fault. Then it carries fault current. It's the reason why, as George said, it has to carry fault current based on table 16. Neutral conductor doesn't carry fault, not supposed to carry fault current. Because as I said, impedance, you don't know where you're standing. Sometimes in design, we have to do U for ground. We don't have place because there is hard rock or clay or water, and try to find way back to DC Hydra electron. So if you understand those fundamentals, you're set. If you have more than one system, like a generator, again, as you mentioned, if we don't have 4-pole transfer switch, only 3-pole transfer switch, neutral conductor between generator neutral and main service neutral will be solidly bolted inside of transfer switch. And we don't have to make a new grounding electrode at generator because neutrals are still connected. And we only bond generator frame as we would bond every motor or every piece of equipment from transfer switch to a generator. But if you have complete divorce, like in a funnel, so you have 4-pole transfer switch, 3-phase and a neutral, then you put grounding electrode at your generator, then you take from neutral of generator bonding jumper, imagine this is a generator, bonding jumper to the frame, and 4 conductors will come to transfer switch from a generator, and 4 conductors will come from transfer switch to transfer switch from main service. And of course, bonding conductors will come to transfer switch from each side. That's it.
Most people are so confused with that
But
configuration.
this is so important.
Yeah,
And
it is.
yeah, even serious engineers I dealt with, they're confused. Now, you have step-down transformer, 347, 600 in a building. Now you have step-down transformer. You have 20-story office building or a big mall. I don't know. I'm not a mall person, so I don't know what it is. I know Kaklita Mall, it's close to my home, so I know. Okay, and somebody says, guys, could you do a little renovation project? And tenant will need a transformer because supply from main distribution or sub-distribution, 347, 600. So we'll give you 600 feeder. Okay, it's existing feeder in a building. So calculate your load, provide, but your load will be 122.8. So you have to put step-down transformer. There is no place to run a grounding electrode. So what do?
Run into the grounding bars of the electrical bars.
So rule 10 to 12, I'll show you, allows, if you have low voltage up to 1,000 volts, and you have step-down transformer, you take neutral of secondary, new neutral, 120 to 8, not 600 volt primary, but secondary. You take neutral and connect by bonding jumper to the enclosure of transformer. This enclosure is already bonded because primary conductors bring, and you allow to connect your neutral with bonding jumper to enclosure, and through the upstream bonding conductor, it will be connected to a single point of grounding at main service. Do you follow me? A rule allows you to do it. This is very important. I'll show you. Anyone has any questions? Because if not, I will harass somebody says, let's go and show us how it works. Are you guys comfortable? Are you sure? George, tomorrow you'll ask. Give it some design with
Okay.
Okay. Guys, this is so important because when I was talking, I realized I understand. I know, but it's so important. I feel you understand it. I can feel it. I'm not, of course, George knows it. When I was 2 years old, George knows it already. But I don't feel if you comfortable. And please ask me again. It's so important. This is fundamentals. And don't be shy. It's not a big deal. Because we have to clarify. It's better to say, I didn't get it. I went to a graduate school, I remember, already in Canada. And we had people, I don't know how they got. And they used to come to me with math questions. And I did my graduate work. I did my PhD in Russia. And I did lots of math because I did dynamic stability of high voltage networks. And I love math. Now I forgot everything, but completely. But I love it. So this guy comes to me and asks questions. And I help him. I don't care. But I'm asking myself. And I said, because I'm a new person, my English sucks. It was 82, I went to school. So, and he was from Hungary, and I asked him, why didn't you talk to a prof? Because what if I'm making a mistake? Because I still learning English. And prof keeps asking, do you understand? Did you get it? So, and of course, I help him, and I will never forgive myself. And I explain, but I am not instructor in this case. I don't know. And of course, it was an exam, and he failed. So he came to me, and I said, we did this stuff. So what he did, he just copied, he was nodding, and I feel that I failed. But I wasn't assigned to be an instructor, but I always remember this situation. So if you are not comfortable, you don't harass your instructor, torture. It's so important because, and don't be shy, never be shy. The more knowledge you get, the more you asking questions. And people say, oh, this person doesn't know. No, person knows, but wants to clarify. So don't always ask questions, because otherwise you create a false impression, and as a result you will suffer. It's my experience. Okay, let's move. I don't know what I do. Oh, thank you so much. Okay. So, separately derived source, which we discussed. Hey, here is your main service, 347-600. Okay, it comes from BC Hydra. We brought neutral, connected to grounding electrode, neutral with bonding jumper. Neutral, connected with grounding electrode. Then we created step-down transformer, primary 600, secondary 120/8. So we created new system. We created grounding electrode. We connected by bonding jumper and connected again to this service. This service, it's a very bad picture because this service should have already connection to bonding jumper. So this connection will continue, but regardless. Okay, and keep moving. And then how many conductors we bring here? 5. 1, which is bonding, 3 phase, and a neutral. Okay. Now, we do the same on that first switch. Here is the first switch, and we're not grounding here. We take neutral from secondary, bring here, and at first switch, oops, we connect into enclosure. From here, we connect in back here because this bonding bus already exists with primary bonding conductor. Okay, and from neutral at main switch, we connect into grounding electrode. But, let's do something else. But if we have less than 750, now less than 1000 volt transformer, 120/8, for instance, right here. Look, we brought same thing. It came in, neutral came in, goes to grounding conductor, same thing. Goes through bonding, goes to neutral here, and goes through bonding jumper to a bonding bus. Same, repeats all the time. It's exactly as I said. Neutral, four lugs. Lug number 1 came in. Lug number 2, grounding conductor. Lug number 3, bonding jumper to bonding bus. And finally, lug number 4 goes to neutral bus at distribution for outgoing. Okay, so far so good. Now, from here, how many conductors we bring to this transformer? Tell me.
4.
Why 4?
No neutral. Because there are no wide transformer.
Do you agree with her? Do you agree with her? I do. Because primary, it's a delta. It's like a motor. It's like a heater. We don't need neutral. So we brought, be confident. I provoke you. It's my nature. Because I want to find the truth. So we bring 4 conductors. We don't need more. But we also bring safety net, which is our bonding conductor. It's a reason we bring 4 conductors. Take a look. This bonding bus, which we brought here, sits here. Now we creating a new system. 120/8. What do we do? And these transformers on 25th floor somewhere in the office. They come to you and you said, have no fear. We don't have to dig ground. We don't have to run grounding conductor. What we do, we'll take this neutral of the system and connect by bonding bus to already existing bonding, by bonding jumper to already existing bonding conductor. And it will neutral will go back right here and will be connected to this neutral. And this neutral is connected to what? Grounding electrode. So by default, your secondary system becomes solidly grounded. It will save you so much money. This is important. And don't forget. So now let's go back with generators. Again, this very badly written. It says floating neutral. No way. This neutral is not floating. It's connected to neutral bus in a transfer switch, and neutral connected to enclosure, and then connected to grounding electrode. But they said that it's floating in a generator. But it doesn't really matter. It's a generator neutral, but it is solidly grounded right here. We're creating, and again, it could be a normal supply. It could be standby generator or backup generator. And take a look. In this case, we have 1, 2, 3, and we also we interrupting. So we've got 1, 2, 3, 1, 2, 3. So is neutral solidly interconnected, or it is disconnected by transfer switch here? What is it?
Solid.
So, you're speaking up. I know it. Exactly. And because neutral solidly connected, as our friend just said, we solidly bolting it through the neutral bus inside and connecting it or here, or if it would be a main system, we'll bring neutral back to the main system where it is grounded. Makes sense? We do the same. If we have a standby or emergency generator completely isolated from this system, completely divorced. I like this word because it helps me. My son went through the divorce and I remember nightmare. So in this case, we would do the same. We would create extra pole here, and pole will disconnect neutral. We're allowed to do it. And then this neutral will be connected to frame by bonding jumper and will be connected to ground. Because we grounding system, it means neutral of a new system of a generator, will be connected to ground. Make sense? Okay. So, and it's all the time. Let's take a look at this picture. Oh. So what do we do here? How many poles we've got inside transfer switch? 4 poles. Can you see? 1, 2, 3, 4. Huh? So we're divorcing one generator from another. We're saying we don't want to deal with you at all. No joint custody of anything. Or you or me. It's like your interlocks between heating and cooling. As a result, we said fine. Each system is standalone. No common connection. No neutral. So what do? Okay, we create a new system. Neutral is connected to ground by grounding conductor. Neutral is connected to enclosure by bonding jumper. And as a result, we bring to our load, here's our load, from here, how many conductors we bring? Exactly, because we bring bonding, because we bring bonding conductor, and we bring neutral. And neutral inside is isolated. Neutral right here is isolated from enclosure because it's isolated here, and we brought bonding conductor. Bonding conductor functions for bonding of all pieces of equipment. Make sense? So those are fundamentals. And if you feel it, you don't have to be concerned about things. And you can do the same for high voltage, except with high voltage. You've got this ground electrode, glorified station ground electrode, with minimum 4 rods, with grid, and with a loop. Why? Because we want to ensure that all our potential fault will go to Earth as much as possible. And we need as much copper as possible, because if this fault as a snake will come back because impedance of Earth is low, it can come to another piece of equipment and somebody can stop and it will be touch voltage. Or we're standing on the ground in different potential, it could be dangerous. It's a reason we normally not only beefing up our station, but we put crushed rock, because it's like semiconductor. We don't want current which will go through the station ground electrode with all this copper to come back. It will hit crushed rock, which is impedance. That's it. It's only difference. Of course, we have to measure step and touch voltages. We have to do test because it's a high voltage, it's implications, because large fault current. And what does fault current create? Huge dynamic and temperature impact, because value is high. And it's a fault current. It means impedance is low and voltage is high. It's a reason why we're doing all this stuff. But objective or fundamentals is the same. Then we have more precautions in high voltage. Otherwise, is it clear? Okay. George, what time you guys doing lunch?
Probably 12 o'clock.
No, reason I'm asking, because I have to take one medication. It has to be half hour before, so I have to be accurate.
Sure. You do what? Meditation?
Medication.
Medication, yeah.
Yeah, I have, it's called acid reflux.
Okay, sure.
It's like gastritic stuff, and they told me, so I have to be, so if it's 12:30 or 1, just let me know, otherwise.
We order lunch at 12. Yeah.
And it's fine, it's fine. I'll do it.
You're okay.
Tell me.
Yeah,
Yeah, okay. I just wanted to make sure. I'm not hungry, just if everyone will eat, and it will be impolite for me to stay. So, and if I'll touch food, I know that half an hour before I have to just take medication. Okay, so.
You want to take a break? Or?
No. Wait, if you're okay, I need no breaks.
Okay, go ahead.
It keeps me awake. So, as long as we understand these fundamentals, we're okay. And I don't care how much you remember, because I can guarantee you already forgot what we talked earlier about changes, about new opacity, new definition, new seismic requirements. And you're supposed to forget, because normal people forget. You don't put this nonsense in your head. But key is to understand what happened. And when you know what happened, you will find it. It is, hey, we talked about it. Then immediately you will have associations. But I'm emphasizing more on fundamentals because it's more important. And before we'll go through, I want to spend a couple of minutes on correlation between section 8 and section 4. So you remember I told you, section 8 deals with load calculations. It deals with circuit loading. All 8-200 series rules deal with load calculations for dwellings, for apartment buildings, for motels, for hospitals, and everything is based on specific loads. Loads in watts per square meter. Why watts? Because we deal with active loads. We don't deal with inductive capacity loads. The only load in KVA, we deal with transformer. Because transformer is necessary evil. It doesn't do anything. You don't connect anything to transformer, it will be hidden. Because it always has inductive and copper losses. You connect, it will be overheated. And you can overload transformer. It doesn't do anything. It's like a translator from Russian to English. I'm just kidding. You understand? So what it does is interface between voltages. Because supply voltage is one, it's exactly what transformer. So we do it in kVA because inductive load is huge. But all other equipment, even generator, we do in kilowatts. We can do kVA, but so all our loads in kilowatts, in watts. In table 14, table 14, it deals with something which is not specifically in 8-200 series rule. Also deals with 1 per square meter. That's it. So we did load calculations. Okay. Then why do we have to know load? Because we have to accommodate equipment which has rating or basic load, which is lighting and receptacles in a building. We have to provide conductors to fit all that stuff through distribution panels. So we have to rate distribution panels. Example, let's say your load is restaurant somewhere, 150 ounces, 122.8. What kind of panel board would you install? So just casual discussion over coffee break. You will say, hey, 225 ounce standard panel board. Why? Because you say, because I don't know what kind of circuit breaker or what kind of fuse will be on the main panel. So I take 150, just in case, multiply by 101.25, and it will give me roughly 200 down. So I take next standard panel. Then I realized, whoops, I have transformer. What kind of transformer will I select? So I'm saying, okay, if I took my load, multiply by 125 and 150, and give me 200 amps. So I'm taking 200 amps, multiply over 0.28, point over root 3, and I will get 71 kVA. What kind of transformer can I use? 75, next standard. So we're already wasting lots of money, but it's a standard. And keep building. Hey, what kind of primary conductors and transformer? 75 kVA transformer, I go to rule 26254. It tells me over current protective device, 26256, conductor size, piece of cake. But in general, it's so simple. So when we select, of course, overcurrent protective device is simple. Rule 8106, 8104, 5 and 6 has only one difference. Both of them talk about rating of the circuit. Rule 8104, but although it says rating of the circuit, it is ampacity of circuit conductor or rating of overcurrent protective device, whichever is less. So if conductor happen to be ampacity 100 ohm, as per 75 degrees, and circuit breaker 100 ohm, rating of circuit 100 ohm. If we have to upsize conductor because of voltage drop, because of a whole bunch of overheating because of 75 degrees, but circuit breaker is 200 ohm. What's the rating of my circuit? 200 ohm, it's the smallest. But conductor we keep upsizing because voltage drop, because maybe ambient temperature. Because normally circuit breaker rating and conductor ampacity should be the same. If your load, let's say continuous load, 995 amps, and circuit breaker is marked for 100% continuous operation. What kind of circuit breaker can we select?
1000.
What?
1000.
1000?
Yeah.
Oh, just checking, because I want to make sure. Do you agree with him?
So what's the total size? Is that 75, right?
I just calculated load 900, I said 58, 978 amps. And circuit breaker is marked for continuous operation of 100%. what rating, minimum rating circuit breaker can I say?
It's more than
It's,
less,
this-
less.
1,000. It's 100% rating, right? If it's 80% rating,
Yeah,
you
it's-
have to select 1,200.
You know why? Because rule 8145 tells you that rating of circuit breaker must be which has continuous marking 100%. So it can 100% work. It's built in such a robust way. So you don't have to connect load at 80%. You can connect load at 100%. So if your load, as I said, 175, right, 975, I select next largest standard value, right? Then, what about conductors? Same thing. It tells me if it's 3-conductor cable or cables Raceway, conductors opacity must be 100%, so not smaller than whatever I said, 975. The only rule 4104 tells you, hey, make sure that your conductors have opacity not smaller than your circuit breaker. So they must be at least 1,000 times, unless you go to table 13. And table 13 tells you, oops, at certain up to 800 times. Smaller conductors could be protected by larger conductors. Do you follow me? Huh?
Got it, guys.
Actually, I had a question on
Yeah.
the continuous marking on a breaker. So if, let's say, you have a 200 amp service to panel, and it's a 200 amp breaker.
Yeah.
And generally in a commercial, you just go 80%. So if you have 160 amp, you're good using that. Just assume it's 80%.
You can assume, you know, it's no margin, 80%.
80%, right?
Well, that's why it's big.
So now if you're connecting, doing your load calculation, and now you're getting 170, is the main breaker on the panel the one that should be 100% rated, or the one that's in the main distribution center?
You select, here's your, it's less now. Then you calculate all loads, all electric heating, equipment, whatever. And your load is at 160 amp. You buy distribution panel. You buy standards. Standards normally 225. So they come with, it could be load center without main breaker. It could be complete combination. Okay. So far, so good. And main circuit breaker also 225 amps. And it has no margin. So you're saying, what load can I connect to my 225 amp panel board? Because not only circuit breakers, 225 amp, but main buses, panel boards, vertical buses, also 225 amps. I'm not talking about brand circuits. Brand circuits, I already know. I know equipment rating, but when I do calculated load, I do load calculation for the entire unit. And here's my load. So I bring panel board. It's exactly distribution center. Okay? So your circuit breaker, if it's 225, and miraculous, if it has marking 100%, which I don't believe you'll find, it's only custom built. But if you find 100%, what kind of load you can connect with the circuit?
Go find the car.
Do you agree with me? You do?
Yes.
Why?
It's 100%.
You guys agree as well? I don't feel confidence. I don't feel vibes. You agree? Because it's not 100%. Now, I'll I'll go through this. I also agree. But I just want us to clearly revisit this rule. Why we agree? We agree because of this rule. Okay, boys and girls, let's take a look. Look at this. It's a beautiful rule. Beautiful. Look at sub-rule 1. Sub-rule 1 says that a rating of consumer service or feeder or branch circuit, it is rating in amps, ampere rating, of overcurrent protective device, which protects this circuit or feeder or whatever. Or ampacity of conductors, whichever is less. If, as you said, you've got 225 amp panel boards, but conductors, you happen to have 4-rod feeding. What's the rating of your panel board? 225, whichever is less. Only because if you collected $5 from everyone, I said, I'm sorry, I only have 20. I'll give you 20. You're not penalizing me for giving 20, but you don't have change. Okay, I'm giving you bigger conductor, but rating is $5. Rating is whichever is less. Okay? Now, look at second rule. It says, calculated load in a circuit shall not exceed ampere rating of the circuit. So if your panel board is rated 225 amps, calculated load cannot exceed what? So far, so good. Okay, but then it's in general. But then we go to sub-rule 5. It says where a fuse switch or a circuit breaker is marked for continuous operation at 100% of a rating of its overcurrent protective device. Continuous load as determined from calculated load, because we treat everything as a continuous load, except for dwelling units. Continuous load shall not exceed, read, continuous operation marking on a switch. So if my bloody switch is marked 100%, continuous load cannot exceed marking on a switch. And switch happen to be 600 amp, what load can I connect to the switch?
600.
Case is closed, ladies and gentlemen. Same for conductors. And except as required by item B only deals with single conductor cables because they have bigger ampacities. So we have to rate them. We have to, and I explained that termination is based on table 2 and table 4. And yet we're allowed to use single conductor cable. So even if marking for cable also shall not exceed 100%. Exception in sub-rule B says, if it's a single conductor cable, 85%, because if you look at ampacity in table 1 for single conductor cable and table 2 for multi-conductor cable, it's almost 60% larger. It's your idea to run a free air rating. And I don't blame you because you save a lot. It's a reason we're saying, we're penalizing conductor because we're terminating it at equipment which is designed for termination in a raceway or multi-conductor cable. So we derating this stuff. If, however, like in your case, your typical panel board is marked for 80%, or not marked at all, it's Appendix B tells you, if no marking is 80%, then continuous load also cannot exceed 80%. It's a reason in 90% of our design, if we don't know that a circuit breaker or fuse is marked for 100% operation, we take load and multiply by 1.25. And of course, we don't deal with single conductor cables I don't know how often you do. So, never, almost never. And I hardly ever seen. And it's only in free air. Of course, you can do it underground, but in the free air. So, what you do, you immediately take a load and multiply by 1.25. If you already have panel board, switchboard, and it's rated, let's say, 600 amp, and main switch or circuit breaker is not marked 100%. What kind of load can you connect to this switchboard? Give me the number. Is not marked 100%. What? No, what kind of load? I gave you 600 amp circuit. Your panel board. You found 600 amp panel board. You come, George, I have existing panel board spare. I want to use it. Let's say it's mine. George says, what is your calculated load? Can you connect? And you say, my calculated load 520 amps. Can you connect to this panel? Yes, why? You said, I have to explain. Don't worry. Here's what I'm saying. You remember when police stop someone? You have a right to remain silent. Everything you say will be held against you. So anytime somebody says to me, I say, excuse me, could you elaborate, please? Could you substantiate? I said, you found completely dusty. Old panel board you want to reuse. By all means, it's certified. 600 amp. You look around, you couldn't find any marking. So, what load, give me a number, what value of load could be connected according to this rule, to this panel? Anyone?
I think you need to also decide your load calculation is the continuous load or discontinuous.
Load always continuous unless it's a dwelling unit. Always continuous. Always continuous.
So if by the factor for 80%.
Tell me the number. I give you time.
What? 480.
Great. You guys got it. So this is what I'm doing. I'm a designer. I'm a project manager. I don't have time. I've got 600 amp panel board with no marking. Tell me, what's your load existing? 520 amps. Out. You cannot connect more than 480. Or you can go to manufacturer, find maybe custom built circuit breaker. Mind you, 600 amp you can find circuit breaker. But you understand? And this is paramount. Next, you decide what conductors do you use. Of course, table 2 or table 4. Copper or aluminum. If you have to do underground, you have also options. Or you do in a raceway, or you do single conductor cables. That's it. And you use appropriate ampacity tables. If you don't want, you don't like those tables, or configurations which unit diagram doesn't exist, you call cable manufacturers and say, listen, could you do calculation for me in accordance with IEEE 835? That's it. The rest becomes very simple. And then, as we discussed earlier, you apply correction factors. It's like inviting people. You inviting 12 people. How much beer do I buy? So you cannot buy 12. Somebody drinks more. Somebody doesn't drink. So you always juggle. Same here. It's a pure practical approach. But our approach is based on provisions of the code because it's a law. We cannot, if somebody didn't get extra beer, it's not a big deal. But if you overload your circuit, your client will say, why the hell did I have to shoot? It keeps screaming. So, and the rest becomes very simple. Don't make it complicated. But what I really want to ensure that you guys are comfortable. You understand those fundamentals. We can talk through the code thousands of times. It doesn't really matter. But if you know fundamentals, you will become excellent, confident designers. You can challenge everyone. You can make mistakes because you know, you feel confident. It's like playing hockey. Okay, you fell. I used to play hockey. Okay, but you know how to skate. You know how to move back. But if you don't know, that's it. You understand? Your confidence disappears. So what my objective is to give you a feeling, because it's such a tasty stuff, all this thing. And you deal with it day and night. You should love it. You should come and have fun and enjoy it and challenge each other, challenge, argue, and ask each other questions. And you will grow together. George can call me anytime. He knows where to find me. But this is extremely important. So, section 10, George, we're working till what time?
3, right?
3?
Yeah.
3 o'clock, okay.
Yeah.
And so we need leave hour or half hour after 3
Yeah.
or before? It's up to you.
It's up to you.
Oh, I'm easy.
I don't know, you guys like to have Q&A after 3 or before 3, so we can check it out.
Yes, we're asking him through the.
No. I'm at your disposal.
Okay. Well, let's start from 2:30.
Okay, so because
If
it will give.
people have more questions, we can extend it
Okay.
to 3:30, or otherwise we finish at 3.
Okay,
What is
so let me go back to. Are you tired? No, not yet.
I'm no.
Okay. Just looking at something which is important. It's all cosmetic stuff. Section 12. What section 12 deals with, guys? Wiring methods. So when we do installations, most important is this section for a contractor. Because contractor has to know exactly what kind of wiring infrastructure is running. Is it open conductors, conductors in raceways, it's armored cable, etc. And we have to know exactly because a whole bunch of restrictions on certain cables. So, there are so many changes. Let me take you through. So it references a whole bunch of rules. And of course I know those rules by heart, but I don't want you to. What it says, if you are installing something in between joists, you have to apply same rules as you installing in a plane. So it has to be FT6 because they're concerned about flame propagation, smoke propagation. Raised floors, portable power cable permitted to be installed on the raised floors, provided cable contains bonding conductor and connection between portable cable, power cable, and other wiring methods made in a junction box. Why? Because quite often, see, portable power cables are used only for equipment which is moves from place to place, not for permanent wiring, except for DLO cable. You know DLO, it's called DLO, diesel locomotive. So huge, like anaconda snake, you take it to your Amtrak, via rail, or to the ship, and it is allowed to be used for permanent wiring only if it is installed in a cable tray. So it will be supported properly. And it marked TC, tray cable. So, but they're saying, hey, we can use portable cable because now with computer, with technology, we have to use lots of portable cable. We can do it under raised floor, under those conditions. Okay, so it gives you conditions. Or roof decking, this is a nightmare. So what happened? Electrical contractor installed wirings in a roof deck. And roof deck, one is concave, one is convex. Roofer comes in with a screwdriver and he has humongous screws. Cable is already installed. He drills into the cable. What do you do? How do you deal with this stuff? And Roofers Association was very upset. They said, you cannot do it. We told them, we don't have control. We install conductors and somebody does, let's say after that drywall installs drywall. Conductors already installed. Can you imagine if somebody will start pushing screws inside? So we do have protection in section 12, whole bunch of provisions. So now we provided, it says, cable raceways in accordance with the section shall not be installed in locations concealed within the roof decking system, where roof system utilizes screws or other metal penetrating fasteners. Because notwithstanding, it tells you where it's permitted and there is a diagram explains. So it explains what it is. So at least it provides help to roofers and it tells you exactly. So it must be warning label must be installed in certain conspicuous location. This is interesting. Type of conductors. So table 19 was completely reorganized. It looks much better. Do you remember table 65? Table 65 deals with enclosure, dry type enclosure, wet type enclosure, whole bunch of stuff. And it has a little cross. It says, oh, you can do it type 3X or 3R enclosure, outdoor location, wet location. So table 19 is reorganized. I'll show you table 19 right now. You love it. Reason I don't want to call it because sometimes it takes me to too many other places.
Ark since you do already here.
That's fine. And just we.
And you need to take a break. You're ready to start for
Yeah.
No,
I'll put
already.
on a screen table 19.
He just take the.
Okay, take a look, guys.
Okay.
It's so elegant. Take a look. So you can go to table 19 and find exactly, depending what kind of type of conductor, depending where it could be used, depending conditions, dry, damp, wet, etc. And it goes all over. It's huge, but it's and of course it references all rules of the code. So it will help you. It will be much easier. For instance, let's say you're using a fire alarm cable. Okay, FAS cable. So can it be installed in communication circuits? You look and say fire alarm cable, control systems, communication systems, fire alarm system, class 2 circuits. Of course it could be, but before it created appearance that fire alarm cable could be installed only in fire alarm system. It's superior than communication. It's like, can I install R90 in a fire alarm system? Of course I can. So you can see It gives you a list of just check marks. It checks everything you need. See? So you've got absolutely everything for every type of conductor, AC90. So it's a very well designed, they're arranging, but meanwhile, I want to deal with you about underground installation. Do you do underground?
Sometimes just for
Just
service.
service.
Just for
So,
service.
question came up. You actually can look at my article I recently published. If you're under slab, is it underground? Of course it is. It allows to install under slab. What you have to do, at least 115 millimeters. But depth from safety point of view, based on table 53, it tells you if vehicles or it's protected cable, armor cable or not. But then you go to D8, D11 tables. It has different
Configuration.
yeah, but this length is based for selection of opacity. So if, let's say, you can do, if restrictions, if you cannot install cable at less depth by table 53, oops, you look at table D18 and you have to go to manufacturer and say, give me different configurations. Because you can actually, from table D18, you can bring cables close to Earth because heat will dissipate faster. But you will say, oh, table 53 tells me 1 meter. If you start digging 1 meter and table D, diagram D8 tells you 760 or 915, oops, if you install deeper, your opacity value will change because heat dissipation changes. So you have to, one table is done for calculation of opacity, it's table D8 or D11. And another table, table 53, is done for safety of installation. And another question, in underground installations, people ask sometimes, what spacing, what clearances? So clearances, you have to go to standard number C22-3, number 7, standard for underground installations, and it gives you spacing. I'll send you, George, right now, during break, I'll send you my my article on this subject. So you'll see, because it will be helpful.
Thanks for sharing.
Okay, so you guys go eat, and what do we do for lunch? How much?
An hour
Oh, okay.
give you more time to install.
Lighting.
Not lighting, the big screen.
LED screen.
Display,
Yeah,
big display.
sign.
Yeah, sign.
Yeah.
Install outside the building. Do we have any specific code or standard? in
No, we
Canada?
do have standard number 207.
207?
Yeah, but I think it's for outdoor signs.
Yeah.
But in many cases, it is integrated assembly, so there is no standard. So sign contractor
Mhm.
makes, so electrical contractor takes a permit
Yeah.
and pulls Raceway
Yeah.
outside
Mhm.
and puts disconnect.
Okay.
After this disconnect, sign contractor comes in
Mhm.
and brings everything inside this huge sign.
Okay.
And he makes it at the factory or right in the field.
Okay.
And this has to be certified by special inspection.
Special inspection is,
SP 1000.
I know, FT1,
SP
so,
1000.
okay.
I'll show you.
And the sign is attached to the building,
Yeah.
or it's on
Yeah.
freestanding
No,
structure?
outside, just on the exterior wall of the building.
Okay.
And the transformers can be installed in.
Yeah, it has. So I'll take a look. But take a look. Table 53 applies to underground installations.
Okay.
And I'll send you my article on this. And safety requirements cover tells you you cannot install cable less than 400 millimeters deep. Why? Because it will be unsafe. Okay? So, but you can do it deeper. So, I'll give you an example. Let's say if you have, for instance, this one, typical 600 volt cable, right? And it must be installed because it doesn't have metal sheaths or armor, okay? But it could be installed underground. So it must be not less than 900 millimeters. Okay, so table 53. But what if we are mark it down 900 millimeters? We're going to table D8. Okay, and take a look. Here we're okay. It's 915. So we're meeting the requirements of table 53, but we cannot install deeper. Why? Because if we will install deeper, then heat dissipation will be reduced and we have to recalculate. So if we don't have configurations which are shown here, we have no option. We have to go back to Rule 4004, and it tells you that if it is underground and conductor in sizes bigger than 1 ohm, so you have to comply with diagrams D8 or D11, or as calculated as per IEEE 835. Why? Because if such diagrams don't exist, so, or take a look, or as calculated as per IEEE 835 method, because such configurations not shown in a code. And this is what I told Mia. In this case, what you do and make custom calculations. You talk to equipment cable manufacturer, and he will give it to you.
Okay.
As far as signs, okay. So you can see it applies to LED type lighting. So, and it has all bunch of requirements here. But if you're not doing inside, then there is a standard. I'm not sure if the standard reference here. But it is standard 207.
CSA 207?
CSA, yeah. C22 number 207.
C22 227.
207.
207, sorry.
I think I just, once again, because new code doesn't have appendix A.
Okay.
Code became so big, they could not list it. So, and I'm trying to download appendix A.
Okay.
Just something happened here. I don't know what's going on. I don't know what's going on. It's stuck. I'll deal with it later. But in old code 2018, you will find appendix A and you will find standard 207. I don't know what happened. But this doesn't work. I can't can't move anything. Okay, guys, we'll talk, but it's clear. So let's go back to table 19. So you can see table 19 has references to many tables, and including opacity tables, table 1 to 4, and all rules of the code which deals with wiring methods. And it tells you exactly, if, for instance, you're in damp location or in wet location, it tells you exactly what you can do. Or if you are let me see. It references, you see, table 19. Then also, it tells you if you are in, again, table 19. But if you're in corrosive location, you have to comply with section 22. And there is a reference to all tables. So anytime you go through this rule, it tells you what kind of cross-sectional area of each conductor you can see for conduit. So it's all interconnected. So let's go back to Memorandum of Revision. So what was done, we got rid of reference to table 19 here because it is referenced later. Rest is all cosmetic, you can see. Cable, conductors, it doesn't really matter. So, then it's special conductors. Temperature must be limited to 60 degrees. And explains you under what conditions. Because why we put this rule? Because product came up this cable. We had to reflect this cable. Temporary interconnections as per rule 76, because section 76 deals with temporary wiring installations. So immediately it gives you a cross-reference. Before, such cross-reference didn't exist. I cannot click here because it's not rule, it's Memorandum of Revision. It's not interactive. What is open wiring rules? You remember open wiring? Open tube. So it's all existing. Nobody makes an open tube now, but we have to reflect it in a code, because many designers still using old installations, and they have to find it. So it was rewritten. Many rules were changed. So I'm just trying to spend time. It's all cosmetic, it's existing. So those little things are completely irrelevant. Then we're dealing about overhead conductors. We, instead of saying maximum size, we put maximum span because it complies with specific table. Overhead installations. I told you about neutral supported cable. You remember NS75, NS90. How to install, because it uses messenger, which is neutral, and doesn't have bonding conductor. But what happened now, because we have only single point of grounding, remember I told you, at one point, and before we used to feed two buildings from one building, and if in a rural area you have to use NS, neutral supported cable, before we used to come, bring neutral, and put new electrode. Now it says, no, electrode only at one place. So equipment manufacturers have to now change standard for neutral supported cable and introduce bonding conductor, because it could be listed not only for service entrance, but could be used in rural area outside on poles. So it created a whole bunch of problems in the court. Messenger's cable, you don't deal with that stuff. So this rule was in section 4. But because it deals with wiring methods, which is use of core, we moved it to section 12. That's it. Protection of cables against mechanical damage. So it deals with what kind of rules? It deals with non-metallic sheath cables. So NMD, typical in residential and combustible buildings. So it only added more provisions for protections. For John, it's important because as a contractor, he has to deal with it. For consultants, it's not a big deal, but at least you know there are some changes for protection. It's all for protection for non-metallic sheath cable. We added a new cable because new manufacturers, Southwire, came with this new cable, and we had to recognize it in the code. And again, I said, it's not a big deal. You don't have to do it because George has all this document.
Okay.
So it's waste. And it says, hey, put protector plate when you deal with armored cable. Make sure nobody will drill it. It's, as I said, all those little editorial changes. Running of cable between its armored cable, between boxes. So they provided more clarification. How do you run between boxes? How do you support? So before we didn't have it. Same with mineral oscillate for wet locations. You will forget it in 2 seconds. But what is important, this document will tell you what was removed, what was added. And when you need it, you'll immediately find it because George will give you all this document so you can see it. This rule, Rule 12.904, some of you remember, but it's a motherhood rule. It tells you separation of conductors. What you have, light conductors, power conductors, or class 1 circuits. Can you do communication circuits? Can you install class 2 circuits? Answer is no, because of different voltage. Unless those communication or control conductors are used for control of those power or lighting conductors. Then they have insulation for highest voltage. That's it. So they added exactly. So control, not remote, but equipment that interconnected and depend upon each other. And the reason why, because in section 16, we added power over Ethernet. And those rules are reflected here. Cables are allowed now to be in conduit. It's, you can, little things sometimes even, and explains that cable tray is allowed to be used means for supporting cables. Why? Because before, if cable on a cable tray, you put tie wraps and nobody knows how to use. So you're on a cable tray, it has little walls, so no problem. Cable could be there. Cable tray, how it's supposed to be supported. Right here, it's nothing interesting. You know what cable bus?
Yeah.
You do, yeah. So it's
That's
a complete
manufacturer
assembly of single conductor cables, but they're supported in such a way so you can buy and use it. And what it was done. It says, hey, what do you do if you have firewall and you have to? It explain. So you have to explain. But what we did, we firewall one wall. So it's cosmetic. Well, no big deal. Again, Rule 12.30, it's the same rule as Rule 12.904. Only 12.904 deals with conductors in a raceway. And this deals with conductors in boxes, cabinets, and fittings. They said, oh, different voltage, don't put it together unless you have a barrier. Same here. Okay. Section 14. Cosmetic, oh, it only says that when you deal with serious rated combinations, some of rated full load currents of any motors in the system connected directly to the point between where serious rated devices don't exceed 1% of interrupted rating. So it tells you, it says, notwithstanding subrule 4012, and 4012 says that every overcurrent protective device which interrupts fault current must be rated for available fault current. So it's a reason on single line diagram we put available fault current. And if let's say your fault current 20,000 amps, you have to select overcurrent protective device with interrupting rating not less than 22K, which is the standard. You understand? But now you have serious rating combination. You know what it is.
Yeah.
So you have big umbrella and small umbrella. This umbrella for George, but I decided to piggyback. George says, okay, I will support you. My umbrella will support you, provided you're not big, you're not too chubby, you're not yet out. Otherwise, rain will create harm to you. So serious rated combination where circuit breaker upstream has capacity to protect smaller circuit breaker, and it gives you conditions. They must be rated for specific requirements, and there is a big appendix B, not explanatory. It's all existing. This is interesting rule. It's kind of so stupid. So look at subrule 1. It says each ungrounded conductor shall be protected by overcurrent device at the point where this conductor receives power supply, and at each point where size decreases. Makes sense. And then provides a whole bunch of relaxations. You remember, 3 meters, 7.5 meters, etc. People say, what about service conductors? Service conductors, but service conductors normally run how? Underground or overhead. And protection of this conductors is not required. And we had in this 14100 another rule I can show you. Subrule G. Really, where smaller conductors supplied by a circuit not more than 750, everything will be changed to 1,000. Supplied from overhead or underground circuit and is run overhead or underground, except to enters building, installed in accordance with section 6, and terminates its service equipment. It doesn't have to be protected. But many people said, oh, we have to put it right at the outset. So, but each ungrounded conductor, take a look. So it says, notwithstanding subrule 1, if you look at subrule 2 in the code, it's brand new. So what we did, instead of saying except, we now writing notwithstanding to emphasize that notwithstanding cyber 1. So that's it. Okay, let's go to section 16. Again, insulated conductors, it's all nothing. Insulated power circuits and insulated conductors of class 1 circuit. It's a politically correct. So we used to have word conductors, everybody conductors. So somebody says, yeah, but some conductors may not be insulated. What conductors not insulated? Only bonding conductors and grounding conductors. So no, we have to do insulating because we're talking about temperature insulation rating. Okay, so right throughout the code we changed insulated. So as I said, I don't want to even discuss it because it becomes redundant. Oh, this is new rule. So if you have class 2 circuits, normally a typical transformer or your power supply for your mobile, even for my laptop, so it must be protected by a fuse. Now it says class 2 outputs must be protected on supply side by overcurrent device set rated not more than 20 amps. So if you plug in the receptacle, you cannot plug into specialty receptacle. You can plug only in 20 amp T-slot or 15 amp. It wasn't necessary, but they wanted, we put it here. Insulated, no big deal. Nothing exciting. I here's not much to talk. And again, this rule 612, same as rule 12904, which we talked earlier, deals with separation of class 2 circuits. So we added for electric lighting, power class 1. Why? Because electric lighting or power could be 600 volt. So, and we don't want higher voltage imposed on class 2 conductors. So it's a reason we mandate insulation. So it's clarification. It's so unsexy. So it's so boring. So you'll fall asleep. I will not because I'm talking. But I don't like it. It's the reason why something interesting will come. I'll show you. Now, as you know, we're dealing with power over Ethernet. And this rule was introduced, subsection 16300 series in 2018 code. So you've been using it for quite some time. So we made some modifications because you've got a power source circuit. So we explained, we just took from US code and added power sourcing equipment cannot exceed 0.3 amp to any load conductors rating of this equipment. Not much. Section 18. Let's talk briefly about section. Do you do anything in hazardous location?
Sometime.
Good. So let's talk about section. I don't want to bore you with this stuff. It gives me a chance to walk a little bit. So section 18 deals with hazardous locations. So which locations are deemed to be hazardous? Where crocodiles or dragon? No. Where there is a hazard, because any sparking or arcing from electrical equipment may create explosive, or now they call it flammable, because NFPA standards change from explosive environment to flammable environment, flammability. But in reality, it will become flammable. You need sufficient concentration of vapors or gases in area. Let's say I have two-car garage, and we have two vehicles, and they are hybrids, but they're not fully electric. So I'm saying, is it my garage? Is it hazardous location? No, because there is not enough concentration of those flammable gases. So we have to determine whether concentration of gases is sufficient for us to treat it as hazardous. Now, I'm asking George, do you know how to deal with it? George will say, I'm electrical engineer. I'm also electrical engineer. And until I joined Stantec, because I was working with industrial group later, I was helping. And I became involved in, there was a guy in Kitchener, Roger, you don't remember? And he was dealing with evaluation. So electrical engineer normally doesn't deal with evaluation of hazardous location. You need people who understand equipment, who understand process, with specific expertise. Only because you're an electrical person, you may not understand it.
Right.
So we put new appendix L, I'll show you. It explains that there's a teamwork. And if somebody tells you, determine whether it's hazardous, hey, you don't take any liability, you don't want to do it. But when you know it is hazardous, when your process experts, what you do? Section 18 now changes everything to flammable, but it deals with flammable gases or vapors and flammable dust. You remember we used to have combustible or explosive gases, but now flammable. Typical flammable dust, you've got woodworking shop, you've got some, lots of dust, combustible dust, electric dust. So it is section 18. But when you know exactly what, another thing which is important, which is old, not very old, but relatively old. Before we used to have class and division. Class 1, division 1 and 2. Now we got rid of classes. We've got zones. Zone 0, zone 1, zone 2. For dust, zone 20, 21, 22. So 0, now it's 2. We added it. It means for dust. Now, if we know it's zone 0, nothing.
Used to be very serious.
Yeah. Well, typical spraying use, where you're spraying zone 0. Then you can move a little bit, and it tells you there's a big table, good table I'll show you in section 18. And it tells you exactly what zone, what classification. It's so important because it tells you how many meters you are away. I remember I was at Stantec, somebody had industrial building, and they decided to convert it into distillery. He came from Scotland, and he wanted to make Scotch whiskey. And it was normal industrial unit space, but now it became hazardous location. So all equipment is existing. So I said, let's take a look. How far you are? How far receptacles? How far line? Where is zone 0? Where is dispenser? Where is actually you creating this potential alcohol? So as long as you know, you go. It's when you deal with it, you go to section 18. It's actually quite simple. And when you know what zone, it tells you, hey, what wiring methods? What can you do? Do you need seals? Because when you are in this area and you leave this area, you have to clean yourself up because otherwise those flammable gases will move. So you have to put seals when you move, not more than 300 millimeters after. So in this case, you will not allow all these flammable gases come from raceways and impact your non-hazardous areas. And that's it. That's an equipment. Before, we used to, you remember any movies with a bomb squad? Huge thing comes and they put inside, so it explodes inside. It's exactly what we in North America used to have this equipment based on class individual. Now, equipment is different. It's IEC based. It's IEC in Japan, in Europe, in China, in Australia. They use IEC standards. So, the equipment is very compact, very elegant. Protection is done ingress protection, so you don't allow anything to move inside of this equipment. So you understand. And different type of equipment I'll show you. It's on there. And of course, section 20 deals with specific area. Oh, spray booths. It tells you exactly how far. Aircraft, hangar, etc. If you've got compressor, if you've got natural gas station or gasoline station, boundaries. But if you know exactly what zone it is, you go to section 18 and do wiring methods and select equipment as per section 18. That's it. So
Yeah, so I worked for oil and gas industry for 5 or 6 years. We deal with a lot of classification. So normally we have a big team, the process guy, or we call risk or hazard
yeah.
people to identify which materials or which equipment belong to which zone or division. And electrical discipline just design based on that we call classification report, hazards analysis report. They will identify with this equipment, this area belong to zone 1 or zone 2, and we do electrical design based on that. Select equipment, design the system, and identify the installation. Right? So we electrical engineer should not be qualified to do that.
Great.
Classification report.
You continue speaking, I'll show you something.
Okay.
You explain to me.
But Ark, we did quite a few reports like this. Even we are electrical engineer, we are not hazard classification specialists.
Of course, and we cannot take liability because we could be. Let me show you in a second.
Okay. Because we have more and more light industrial projects. For some like painting.
But you may have occasional gas station or spray booths.
Right.
At least you know. So because guys, you are generalists, you're a consultant. Somebody comes to you, of course, you will not do, let's say, sewage treatment plant or something else where you deal with control, with instrumentation, with the process. It's not. We're building engineers.
Right.
So, but in general, everything what is covered by code, you do this. Okay. Let me show you.
No, there is no class in the new code, right? Just a zone.
Zone,
No
zone,
class,
zone,
no
yeah.
division, just zone. Okay, that's easy. Otherwise, it's so confusing.
Okay, what I wanted to show you, take a look. Take a look, guys, on the
Oh, that's
screen.
great.
Yeah.
This is new for the new code, or it's already there for 2018?
I can't remember. I think it's existing. It was in 2018.
Oh, okay.
See, those are stakeholders. It's not necessarily electrical.
Okay.
Take a look, exactly what you said, George.
Oh, okay.
See,
Process.
and take a look.
There are no electrical?
Read, other than electrical engineers. So electrical may not be qualified. So it's a serious stuff. Training, responsibility, so documents, records.
Okay.
So it's Appendix L, at least, you know.
I didn't read this before.
Yeah, it's very important.
But we have a project that WorkSafe BC guys asked the client to hire an electrical consultant to do this. So
Classification, no. Electrical consultant cannot do. It's illegal. It's like electrical consultant will do seismic report. It's not your discipline.
okay, good to know.
Yeah, you can hire seismic engineer.
Okay.
You can hire somebody if you are capable to do it. As I said, when I was, his name was Roger Langlois. You don't remember? He was working in Kitchener, Stantec office.
Okay.
So, and I became involved, but I had to read all Petroleum Institute protocols, NFPA standards,
Yeah.
National Fire Code.
Yeah.
So, and I only started a little bit, but you need years and years of expertise in this area.
Well, but we can still provide a consulting
Of
service
course, yeah.
for electrical installation, equipment selection, and installation.
But
From the electrical
if
perspective.
you know classification,
Yeah.
life is easier.
Yeah, for sure. But we can identify classification, zone level,
If you
or
feel
boundary.
comfortable, but I wouldn't advise. Why do you need this liability?
Yeah.
Let your client hire somebody and tell you. And client says, oh, it's hazardous location.
Okay, I understand. Good to know.
So who will then do the classification?
Hmm.
Who can do the
There is a list of, there is a list of
Engineers, yeah.
processes.
It's right here.
process?
Someone who know the process, who know the product, they can be familiar with the process, how this project operate, and what type of materials. Not only process engineer, chemical background. They know the process.
For instance, many documents I had to read API, which
Yeah.
is American Petroleum Institute, and they published. You can see many IC documents. But what I wanted to show you, a table. It deals you with groups of gases,
Yeah.
liquids. Wanted to ask, because quite often, guys, quite often questions come, is diesel hazardous, does it create hazardous location? Answer is no,
No.
because diesel is combustible but not flammable. Here, everything what you see, it's all flammable. You can see flash point completely different. So combustible, it's diesel is combustible. It's the reason why all our emergency generators
Yeah.
could be installed everywhere, no problem.
So we
But
don't
it's
treat,
Yeah.
we don't treat the generator room as a classification.
Exactly.
Excuse me, is a combustible
Diesel
and
is
then the flammable? What's the difference?
Hmm?
What's the difference, the combustible and the flammable?
Who defines
What's the difference?
difference? Flash point.
Yeah.
Flammable.
It's
Flash
exposed.
point.
Flash point.
Yeah.
So flammable will
It's
will be flammable much sooner. For diesel, you have to go more than 93 degrees Celsius. And you can find it, you can find definitions. You can Google, it will tell you right away.
You are the Google. You are the Google.
I don't, because I dealt with it before Google. I don't trust Google.
Oh, you trust the God. Now you're suggesting me ask Google. Ask you.
No, but if anyone, for instance, my grandkids, we discussed it because they started driving. So, and I said, there's a big difference between them. What's the difference? So to me explain, I said, Google it. It's
Google knows us.
But when I tell about flashpoints, they in different. One of my grandkids came to me and he said in schools they told them there are 21 gender. I said, I study biology and I love biology. As far as I know, there's genetically you can be or male or female. It's impossible. It's impossible. Even if you go through some transition, so it must be only 2 genders. In school, they teach him 21 gender. I don't know. So I told my son, what the hell are they teaching? Do you know?
Oh.
So I'm really
How
concerned.
many 21? This is 7, right? LGBTQ, 5.
I don't care how many letters. We're all people. Do what you do, but biologically,
Only 26 alphabets. You're
genetic,
already at 21.
yeah, genetically. I remember Trudeau even got confused. He started to, because we live in time of political correctness. Drives me nuts. They're saying that it is pandemic problem of unvaccinated. I'm saying people have three shots,
Yeah.
and they get. I have a friend, and they became sick. So it's all virtuous signaling. No, you know what? I go to the gym, so it's closed now. But anyway, so they said no, you can't attend. Okay. Next day, it started on December 18th. I went to the Safeway, or Superstore, across. Before Christmas, people literally 2 inches from me.
Yeah.
I'm saying, if there is a problem, you have to regulate traffic. So you go to the gym, they ask your vaccination and wearing mask. You go to the shopping mall. You don't need anything, and you could be 2 inches away. And I'm asking myself, where is the consistency? Where is the science? You go on a plane, you have to be vaccinated, mask, and plane has the best recirculating system. You don't even need masks because it's circulation of air, which is important. So masks don't help. It's a virtuous circulation. Surgical masks or like your mask, they may help. Rest is useless. So you go on a plane, precautions are crazy. I went during snowstorm, I couldn't drive, and I had to go for a cortisone shot to Burnaby. And I took a SkyTrain. Thousands of people, inches from your face. Nobody checks you're vaccinated, nobody cares. And I'm saying, what kind of hypocrisy? One train keeps more, it contains more people than one aircraft because it's like anything else. So let's stick to what we know.
Policy for control.
So when you told me Google, I said, yeah, you can find out, but difference between flammable and combustible, it's an NFPA standard number 30 and 33. They deal, one deal with flammable, one with combustible, and you can find whatever you need. So,
So Ark,
yeah,
if client is unaware of these hazardous location and let's say either WorkSafe BC or they themselves come to us and say, hey, how would you do this? It's depending on the industry, like you mentioned, a brewery, distillery, woodworking shop, like some kind of a cabinet making where they have spray paint booth. Are there some companies where we can recommend they can do the hazardous classification?
we do have process engineering people who actually specialize
So
in this
those
area.
processing engineers, we kind of like they will cover food industry and other.
Yeah, they do. Some are specializing in sewage treatment plants or lift stations, some in breweries, some in grain elevators. So some people do it generally because they're actually insurance underwriters. It's exactly what they do, industrial insurance. And really good, and you don't have to have degree. You have to have practical experience and understand documents. It's a specialty. But as I said, normally, residential became completely exempt because residential, we have houses with 4 garages. Still, it's below because you have to make 2 steps to get into your house. Always. It's a reason because in hazardous location, we have to have good 50 millimeters separation. But key is concentration. If concentration of those explosive gases is actually sufficient to create explosive or flammable environment. That's it. And sometimes if we cannot determine, we don't determine.
When the word combustible dust was added, and got me thinking of a lot of basically just renovations where it's a cabinet making shop. So it's under the pretense that okay, a mechanical engineer is there, so they install the dust blower, the dust extraction fan. So as the electrical, is that just good enough? Because nobody mentions any hazard. There's no talk.
No, actually, interesting you mentioned. You can create positive ventilation. Exhaust fans will work. It means that even it is described or defined as zone 23 or zone, you understand? 21. Still, you may use wiring, ordinary wiring. Same, I'll show you in a second. I just wanted to show you table, interesting table. It's in section 20. Just give me a second. Here's table 22, talks about type of, if you have stables, you have stable for horses, you've got all other areas. It creates or corrosive or wet location. But in section 20, I was looking for a table which gives you distances. Maybe I missed it, but doesn't really matter. So you'll find it when you'll deal with it. But what I wanted to show you, rule 18. It will take me through entire appendix.
Okay, you can keep going.
No. Okay. 1868, yeah. 18070. Take a look. Read it. Electrical equipment suitable for non-hazardous location shall be permitted installed in zone 2 location. And electrical permitted suitable for zone 2 shall be permitted in zone 1, provided that no specific equipment suitable for purposes available. It means classification remains the same. Classification is the same, but equipment and wiring could be relaxed under condition A, B, C, and D condition. And most important, this condition. Take a look. So, and this is exactly what you do in a woodworking shop. You're saying, hey, you've got ventilation, and ventilation creates environment where wiring methods complying to section 18 are not warranted. So it's all there. So the reason we stopped to to pay attention, because I don't want to spend too much time on, oops, where am I? Because it's so much in, and you will not remember a thing. Okay.
That also got me thinking on certain other areas, like, so a restaurant will put a patio, so it's supposed to be outside, but then it's Canada, so it's cold, so they put radiant heaters, but sometimes it's really cold, so then they enclose the patio. So those gas heaters, they don't have direct venting, they're all indirect ventilation. So unless that patio also has an exhaust fan,
Right.
your electrical scope could actually go into hazard
But
location.
most likely, it's most likely zoning requirements are very restrictive. They will not allow you, those heaters, gas or electric heaters, gas heaters. But nobody uses gas heaters. It's mostly electric. 99% electric. So
Quite a bit of restaurants, they use
gas heaters,
gas heaters.
well, maybe, but
They like those sectional, because electric, usually the panel is not big
But
enough.
it is done only in those areas which have access to outdoor ventilation.
Yeah.
And we're really cold, because if it is inside of building envelope, inside of floor area, it will not be allowed. Section 20, we went propane, few definitions, nothing exciting, I'm just looking. 22, electrical equipment, we changed type of construction. Nothing to talk about it, I'm just looking. Wiring devices, connectors instead of receptacles. It's cosmetic, receptacles and plugs. I will concentrate, this is important. This is important. This is a brand new subsection. So, before we couldn't come up with rules for farm buildings. Let's say you design and somebody calls you and says, guys, could you do for me electrical design? I have a little farm, pig farms, or maybe dairy farm, and I need electrical wiring. So you'll do with this new rule. It tells you exactly what kind of livestock, it tells you exactly what it deals with. Okay, and then classification of area, I will not go through, but at least it helps you. It really helps you. And then it will take you to specific rules in section 22. It tells you whether it's category 1, which is wet location, or category 2, which is corrosive location. Okay, so, and it tells you exactly what cables allow. If you may not be allowed to use EMT, you have to use PVC because it's non-corrosive. So those little things, but at least it's here. Section 24. Do you do anything in healthcare facilities? Hospitals, clinics?
Not too much in our company at this time, but like
Yeah, I
we did a lot.
Okay, so let's say section 24 applies to patient care areas of healthcare facilities. Take a look. Patient care areas of healthcare facilities.
So it doesn't include typical clinic, right? Typical clinic. What about
Yeah, if it is patient, because all these areas are defined. 24. George, not only clinic, but typical office. Office, even I was passing here somewhere, doctor's office. If patient comes, except if you're Sigmund Freud, if you're a psychiatrist, then you don't use electrical equipment, you use couch. So you're a psychiatrist. In this case, it doesn't apply. But dental, anything, massage therapy, anytime you connect equipment, You put equipment which is plugged in to look with light into your nose and your ear and your throat. You have to make determination to what extent. So bonding must be only with bonding conductor, copper conductor, no aluminum. All bonding buses must be inside of patient care area. Everything must be bonded together. So we don't want any leakage because different patient, high fever or medication, different fibrillation creates problems. So very restrictive requirements. But question is, what about barber shop? Is it patient care area?
I don't think so.
Why not?
No patient.
Exactly, because it's not governed by College of Surgeons and Physicians. It's not governed. What about Botox? Botox, you do injection of, somebody asked me many times, they do. So you have to see who is doing it, under what conditions, because sometimes they do Botox, how do you call it, plastic surgeons, they do it in patient care area. Sometimes it could be like manicure, pedicure, something like that. What about tattoo parlor? They can do ink, sometimes with electric machine, sometimes with pneumatic. So everything must be regulated. What about animals? It only deals with people. I know. Some animals are treated better than people, but what I'm saying, so it only applies to patient care area. And again, requirements more restrictive.
Yeah.
And what is interesting in this section, many decisions are given to healthcare facility administrator or administrations, especially unit. They're responsible because it's a performance. Because Z32, Z32, it's a standard for application of electricity in healthcare facility. Deals with those requirements. So anyway, we will not touch it because you don't need it, but we made a few small changes. Section 26, our favorite section.
Question on
Sorry, what?
that. What was it? The Z32 standard
Z32.
testing?
Yeah.
Testing of electrical equipment in healthcare facilities.
Yeah, it's not, we don't test electrical equipment, but we're testing voltage drop bonding because we don't want voltage drop to exceed certain parameters because if we have large voltage drop, it means we have leakage somewhere and everything is bonded. You don't even use isolated ground receptacle. Sometimes you allow grounding prong, run separate bonding conductor, don't connect it to a box. In a healthcare facility, under no condition, you cannot use isolated ground because difference of potential is too big. You have to bring everything like in a hydromassage tub, current collector. Everything is bonded together. And then they test voltage difference because they have to ensure that under no condition difference is too big because otherwise it means somewhere leakage of current and it may impact people who are under special medication. Okay.
Even some of those like dentists, like if you do like a dentist offices, they have all these patient chairs.
Yeah, patient chair, normally it's a hydraulic, but there is lots of electrical as well. And
also like the sink, kitchen sink, and
Yeah.
also their sink
Yeah.
and like
if sink
right
has any lighting, electrical controls, it must be bonded, metal sink. If nothing comes close, doesn't have to be bonded. So sometimes, there's a drinking fountain or fountain to actually gurgle. it actually remotely connected like here sometimes. And you've got class 2 circuits even in your washrooms. You have it, you put your hands. So oops, this must be bonded because there is a small but current exists. And dental area is considered to be not even a basic care, it's intermediate care. So bonding requirements more restrictive than for basic care.
So should we ask for like a Z32 test report, like what as consultants?
Yes, because dental office or even hygienist office, it's absolutely, it's a clinic. So you apply section 24 requirements because persons who came to do now, they don't do it after COVID. I don't know, did you do teeth cleaning lately? No, but after COVID, they don't use any electrical stuff. They're not allowed. They do manual, everything. Yeah, but when COVID will be over, they will come back because their productivity went down. Or I would say effectiveness went down. They allocate 1 hour for person regardless, but do much less. So
I have a question from your clinic. So who will take a check if you apply to the Z32?
who applies?
Who will check? So we do design, for example, we do design, we didn't follow the Z32, but later who will check if the design or the installation
inspection.
is
Oh,
do the
inspector doesn't care
Just
because
prepare
Z32 is not referenced in the Canadian Electrical Code. It referenced in Appendix B. But inspector said, no, we don't care. We don't want to do testing. We don't need your bloody reports. It's up to professional engineer.
Yeah, as an engineer, we'll take all responsibility.
And you have
liability for that.
You have full control, full responsibility. I'll show you.
So if we don't see any report, it's kind of our decision not to ask for it.
So we have to take full responsibility.
Hmm?
We have to, as a consultant
Yeah.
or a record engineer.
I don't know what happened. I cannot send. Let me see. Maybe I'll do another one. I don't know what's going on. I don't know. I don't know what happened. I don't want to close my computer. Anyway. So, I wanted to show you that 32. It says, engineer, all testing must be acceptable to engineer of record. So you become, in a way, authority.
I've done a lot of dentist offices, and I always write that before final acceptance. I want CSA Z32 test report, and always the contractor fights me over it. Where is it? Show me in the code.
In a standard, you know what? I can actually just close everything. I don't know what's happening here, but something doesn't work. I cannot see. I don't know. I cannot send email. I don't know what's going on. So what I want to do? I wanted to send two of you guys. No, I'll leave it. Two of you guys sent. I don't know what's going on. I wanted to restart.
It's okay, we can do that later.
Yeah, a reason why no, but I wanted to send you that 32 to show. I'll send you that 32.
Okay.
Okay?
Let us that this is not because some other consultant maybe.
Okay, let's move.
Yeah.
Let's move. Section 26. Also cosmetic things, I'll tell you something. This rule it's not in accord because it is conditional to rule 8106, but people who submitted proposal, it's only memorandum of revision. It's what the committee approved, but in the real code, you will not find it. Okay? Now, everything related to batteries was relocated to section 64 because battery is alternative energy. So, finally, they recognized secondary suites. So explained here, panel boards and dwelling units. But if you don't have to put panel board, if you have a secondary suite, you have to have one panel board, which is installed in the main suite. So owner will have control. In a secondary suite, it's not necessary. But if you want, by all means, because it says must be installed in dwelling units which have been created by subdivision of single dwelling, which is secondary suite, and not individually metered. So in this case, in this secondary suite, which is not individually metered, you don't need panel board. It could be installed in the main. Again, flood hazard, we put rule. Oh, this is political rule, smoke alarms. So what happened? Sometimes you have single dwelling and secondary suite, but essentially it's part of your dwelling. You just allow somebody to live. And smoke alarms supposed to be in main dwelling and secondary suite, and they interconnect. But secondary suite may have its own panel board. And you cannot sometimes interconnect smoke alarm because you can create short, because it could be connected to a completely different hot. You understand? So we wrote this rule that if you have secondary suite, normally you don't allow any devices from one suite to be connected to another suite unless it is a secondary suite. Then you can take smoke alarm and connect to the circuit from main suite where another smoke alarm is connected. We just explained because nobody wanted to deal with this rule, not in section 32, not in section 26. So edit another GFCI.
So now we have GFCI for all rooms in residential.
AFCIs.
Yeah.
AFCIs.
Yeah, yes.
Yeah.
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 Not only inside the bedroom,
Yeah.
even in the kitchen, living room, everywhere.
Kitchen is accepted, right?
Yeah, it's nothing changed from existing 2018 code, all except for certain things in the kitchen, because nobody wants. But now many contractors send proposals. They want remove FCIs because dishwasher machine doesn't work, because new with sensitive electronics. And you know why? And everyone is scared. Before political correctness, everyone wanted to use FCIs, but they never worked. And I know when I was with the city of Vancouver, contractors put FCI, inspections done, removes it, puts in another one, because they never work.
In chip.
Three. So now receptacle type AFCIs work better, and actually they're better because biggest problem were extension cords, jamming. But Eaton put pressure because they made millions and billions of dollars, Eaton, because equipment was bad. Siemens AFCI, I cannot say it, but not very good. Eaton is okay because they perfected. But they made so much money and they put out of business receptacle type of AFCI. Now receptacle type of AFCI found a way, so it's already recognized by the code by 2018. So it's politics everywhere. So, GFCI protection. I was approached by City of Vancouver Engineering Department recently, 4 years ago. And he said, Ark, we've got the Christmas tree lighting on our trees, all this Christmas decoration. And people get shocked because we put in receptacles. So I had to change the rule. Before, we used to have outdoor receptacles at dwelling unit. Now, absolutely everywhere, everywhere. So, no dwelling units. We got rid of dwelling units. It tells you where GFCI is supposed to be installed. Before, it tells you, hey, showers, sinks, 1.5 meters. Now, say, all outdoor receptacles must be provided with GFCIs.
Yeah, that's what we did. That's what we did. All the GMs as approved.
You remember I told you that in Burnaby this morning, Stantec was doing 42-story building.
Yeah, we talked about that.
And they never put receptacles in a stairway. Take a look, item M. It is deleted now. Because I told them, I put a proposal, but by the time I put proposal, it wasn't adopted. Something else I want to tell you, something very important. Look at this one. So no more requirements for sprinkler protection in service rooms. Room is deleted. You remember I told you, you have to put shields, hoods,
Yeah.
if equipment is in a service room. But if equipment is not in a service room, somewhere else, you don't need anything, which is crazy. Okay, so this is important. Section 30, not much, it's just purely cosmetic stuff for switches. Oh, one thing is bad, because we used to have requirements for switches and lighting in dwelling, in residential dwellings. They said, no, it's in the building code. So contractors complaining, I said, because I'm chairing this committee, I said, guys, I introduced all these rules. They decided to get rid of them. And now contractors are screaming, they said, we don't have building code. So, but we deleted the rules, I said, fine. Okay. Bonding jumpers, we talked about. Section 32, firearm system. Let me see. Before, smoke alarms used to require compliance with Rule 32-100, which is firearm system. And I told them, people, it's a bloody smoke alarm. It's in your branch circuit. What does it have to do with firearm systems? I said, oh, okay.
Right.
They got rid of this one and said comply with section 12. And it's a little thing, but people become, they say, smoke alarm, must comply, only copper wiring, only. Why? There is no reason.
Some people mix up the smoke alarm with the fire alarm. They thought that there are one system.
Okay. You remember I told you that somebody was working and a person was electrocuted because high voltage was energized. So we put fuses could be energized either, it's Rule 36-8, from either side, isolating, disconnecting means. And so it's additional requirement because of coroner in Ontario providing these requirements. 38, you don't care, you never deal with it.
What's that?
Elevators.
Elevator.
No, do you do elevators upgrade?
We have residential project which need.
Yeah, but what you do, you only put disconnected means, but upgrades of elevators, you don't do it.
No.
So that's fine. Section 40,
There's no section 36, no updatable
section 36.
Yeah.
Only I told you, interlocks, fuses from other
Oh,
sides.
yeah.
You remember because of it. Section 40 deals with what equipment? Cranes. Nothing exciting here. Nobody deals with section 40. Section 42 deals with welder equipment. We just clarified welder equipment. It's all here. Nothing. It's a stage equipment. Production theaters.
Okay.
In a stage. Nothing. And it's just very small. Section 46.
Fire pump, is it?
No.
No, emergency
No.
power.
What happened? I introduced the sub-rule. You remember in section 32, we have a rule says that fire pump feeder on emergency could be connected upstream
Yes,
of emergency generator.
right.
So I said, oh, diagram is shown in section 46. So let's do the same rule because we reference rule 32-306. It says, in this case, if you put feeder upstream of main breaker, you don't need selective coordination.
Yes.
It's so we just added it here. Communication cables, nothing. It's for community antenna. It's not, it's community antenna. Next one is optical fiber. Nothing, absolutely nothing. Insulated. Next one is 58, which deals with, you probably forgot what it means. Section 58 deals with lifts,
Okay.
ski lifts. So it's a new section, used to be different. Okay, section, not much. Section 60 wasn't touched. Section 62, new definitions of heat cable, trace cables.
Sometimes we need this
Very cosmetic, nothing else.
only for garage, for sprinkler system.
Yeah, heat tracer. It's when you do tracing, heat tracing, asphalt. And you've got a bunch of requirements about maintenance, about repair. So that's it. Non-heating elements, temperature control, heat tracer, impedance tracing. It's all existing, but they put new requirements because it came from US. It was a standard. They put new additional requirements, but you don't deal with impedance heating. You know impedance, so it's like induction furnaces. Impedance. Speaking of impedance, Mia asked me, when do you have? We have resistance grounded system.
Yeah.
Ungrounded system.
Right.
So if it's above 600 volt and no neutral, or even 600 volt, you can do ungrounded or resistant impedance.
High impedance, low impedance.
Yeah,
That's
and,
useful.
and impedance is important because you insert impedance between neutral and grounding electrode.
Yeah.
And by doing it, you control
The
current
ground fault current.
Yeah, exactly. And why it's beneficial? Because arc flash problem disappears. Because highest arc flash if system is solidly grounded.
Yeah.
Because fault current divide over zero impedance. Oops.
And the other reason why we do that is for most industrial project, you don't want to have the whole process.
Right.
So even there is a ground fault to a pump or to a motor, you still want to keep that running. And the ground fault normally is not a permanent. It can disappear automatically. So
Exactly.
you still want to keep that.
Yeah. And it's very important if you deal with industrial plant, particularly where I like this thing called the button. If you deal with industrial application where you got big exhaust fan, people in a mine or in industrial production plant, you may have a serious problem. Why? Because you cannot shut it down, even if the ground fall. You want it to keep running. If people in elevator, in a lift, they have to get out, you cannot do it. So that's the reason. Okay, section 64, energy production. We added a new, completely new subsection, energy storage. I want to spend a little bit of time, this cosmetic. So we deal with PV, we deal with every type of inverter-based technology. But we also created new humongous batteries. We call it energy storage. It's like a capacitor. So we created new rules. Rules are not very technical, just you have to go through all that stuff. I'll show you. PV, some cosmetic stuff. Batteries, we transferred, remember I told you, from section 26 to section 64. Now, battery, it's all okay, it's all from section 64. A new subsection, energy storage. So self-contained and field assemblage energy storage system. So nothing technical. It tells you under what conditions could be installed in a dwelling unit, in a commercial unit. I can read you, but you'll forget in 2 minutes. At least you know, pay attention. But there is no serious technical requirements, only marking, explaining what to do, but that's it. Overcurrent protection, go to section 14. Disconnecting means exactly what you do. Make sure that disconnecting means could be disconnected from 2 sides, because energy system could be connected to utility. Same as section 84. So nothing, no technical rules. And again, what protection must do, bonding, again, reference section. But key, and very important, it's subdivided, how many kilowatt hour energy, because it's like a battery. So, and under what conditions you have to maintain it, how to space it, it's all here. Special diversion load controllers. As I said, nothing technical. It's like instruction. You go to IKEA, it gives you instruction what to do. So here, you buy new Sony TV, it gives you instruction what to do first. That's exactly what it does. Working space, that's it. Section 66, single conductor cables. It's for carnivals, for movie sets, nothing, it just. Section 68, swimming pools. Also not much. We added raceways, insulated conductors, junction boxes. Instead of acceptable, approved, we put suitable. It's all politically correct stuff. Section 70. So 70 and 72, one deals with non-relocatable structure and one relocatable structures. So it's very cosmetic, very cosmetic. See, recreational vehicle. Mm-hmm. So if you have a fifth wheel or trailer and you put in a trailer park, we put new definitions explaining how to do load calculations. So it's almost like section 8 or mini section 8. But again, you follow the rules, it's very simple. because you deal with specialty receptacles. Sometimes you put 30 amp receptacle or 15 amp receptacles. Parking lot. Next one, 74. Nobody deals with it for ages because nobody knows how to deal with it. You know what it is? Airport installations. We do have people, but they have their own rules on the field. Nobody follows. 78. It's a marines and piers and docking facility. Nothing. 86. Electric vehicle. So now we will allow more than one electric vehicle to one circuit. So what I do allows conditions and tables. I'm done, but I want to spend a couple of minutes on electric vehicle energy management system. So what we did, we put this sexy description and said, hey, you can reduce your loads in your calculation. If you put energy management system, let's say I bought energy management system and all of you sitting here, you are electric vehicle loads. I didn't count how many of you guys, how many? Right now?
Right now,
16?
14,
14, okay,
15.
14. But, and each electric vehicle supposed to be minimum 40 amps.
Yes.
As to 40, you know. Okay. So, if you take 14 times 40 amps, it's what, 560 amps. Okay, let's do 20 for fun. So 20 vehicles, 40 amp, 800 amps. But I don't have too much availability. My service is loaded. Plus, I have to reduce my service size because I don't have place. I also may have existing building. What do? So I said, rule 8106 sub 10 tells us, you can reduce demand on electric vehicles, provided they're controlled by electric vehicle energy management system of a specific rating, and you only can use rating of this system. So I said, great, I buy a system which will be controlling all my roads, and let's say 20 vehicles, but I will connect, and my system is rated only 400 amps. Holy moly, I'm saving 400 amps of load. I will connect, I will feed all 20 vehicles, but only if one already ate pizza, get out. You want dessert later, let somebody else eat pizza, you understand? So this thing controls to the extent so your electric management system will not be overloaded. So it cannot, it's like demand control. Will control loads, okay. So far so good. So it's one system, but nobody knows what it is, where to buy it, where to specify it. No standards. I'll send you this article or tonight or tomorrow because I've got another commitment I have. But tomorrow for sure because I still have your email address. If I lost yours, Mia, I've got George's on this computer. Okay. So, and second, electric vehicle management system, it's even more interesting. It says where it monitors load on a service, monitors load on all feeders, and controls electric vehicle loads. We can completely disregard these electric vehicle loads. You can say, holy moly, this is amazing. We now we can come to the owner of existing building and say, look, we've got this sexy entity, energy management system. It will control load on your service, load on your feeders, and if load will, normally it's not loaded all the time because people will over the place. If load will approach rating beginning of your service, we will disconnect those vehicles who already fully charged or half charged. And we will connect those electric vehicle loads only when load on feeders, on service is not up to rating of the service. Everyone is happy because we will completely disregard. But nobody knows what the hell it is. And CSA cannot produce standard. So what you do, I don't know how you do deal with this stuff, but there are manufacturers
Yeah,
who come.
we talk to manufacturers, they have their own EMS.
Yeah.
But there are different type of such a product in the market. Like Flow, they can do that from their EV charging side, and the other vendors, they provide EMS between the panel and the EV chargers. So it's quite different.
But be careful. Make sure that those people who supply you will provide you verification report. It's like fire alarm system verification. Why? Because otherwise you will become liable. You have to make sure that they can demonstrate that system, energy management system, actually performs to meet all conditions of sub-rule 8, 1 or 6, 10 or 11. This is important.
Okay.
Okay, guys, I'm open for any questions, any discussion, because I have to leave at what time is it? Yeah, 3:15.
3:15.
Not later.
So we have 20 minutes
Almost half hour.
for questions.
Yeah.
Okay,
Anything specific?
come on, guys.
So for the cable or the conductor for the knife safety node, do we need like a special MI cable
For
knife safety node? So for emergency, we do have non-knife safety, right? That have
Yeah.
knife safety. For the knife safety node, do we need like a special cable, like for example MI cable, or we can put the Ark for the in the
this
conduit?
is interesting subject. We will need at least 1 hour on this subject. But brief. So why do we have to protect conductors? Why do we have to protect conductors against exposure to fire? Just think out loud. Why?
We want to keep
Yeah,
the
we want-
adapter
yeah.
to be optional
Yeah.
when there is a fire.
No. But what George is saying that hey, certain equipment must perform during the fire.
Right.
Because normally there is a fire, how many stories here?
Two.
Two stories. If there is a fire,
People can
you leave.
leave right.
You leave. Fire alarm system, we don't care. We leave immediately. That's it. We don't have to protect conductors. But in certain buildings, ability to leave immediately is not practicable. And we call such buildings high rises. So, building code article 32710 of the building code says, hey, if we have a fire alarm system in high buildings, emergency lighting in high buildings, smoke control, smoke venting equipment in high buildings, riser conductors which protect fire alarm system riser or emergency lighting risers must be protected, because if fire on floor 26, for instance, everything is fried, we don't care, but we want this emergency riser to supply other floors with emergency lighting, with fire alarm system, and smoke control, smoke venting fans must operate. So conductors which supply smoke control, smoke venting fans must be protected. And those smoke control, smoke venting fans must be in a fire-rated service floors. Everything for 1 hour. Only 2 places we need conductors to be protected for 2 hours. In areas of refuge, in hospitals, because in hospitals, situation is more difficult. You have to take people who are infirm and shuffle them in special areas of refuge and we need air supply for 2 hours. So this air must supply provided for 2 hours. It's the reason why a generator must have fuel supply for 2 hours, even all other equipment 1 hour. Okay. So, and it's the reason why those conductors to this type of equipment must be protected for 2 hours, because we're expecting equipment performed for 2 hours, because people in area of refuge, it could be in a hospital or give me other place where people could be kept for more than 2 hours.
Our pump,
What?
our pump.
No, for 2 hours. Jail.
Oh,
Because,
jail.
hey, I got 25 years of solitary confinement. And I said, well, there's a 24 more years. So they move them into area. And because those people are capable to do everything, but they're not allowed legally to move. In a hospital, people incapable, or mentally or physically. So. But it's illogical. So we provide protection of conductors. Let's say emergency lighting comes to the floor. Are we protecting conductors on the floor? No, because if there's a fire on the floor, too late. Everything will be burned. And equipment and conductors. But we're protecting riser conductors. For life safety equipment like firefighters, elevator, smoke control, smoke waiting equipment, fire pump in any building. If building is sprinkler, and sprinkler requires fire pump because pressure is not sufficient, even it's a single story building, if there isn't not enough pressure, fire pump is required. We need a generator, and we need fire pump in a fire-rated room, and we need to protect conductors for 1 hour. So, only those conductors must be protected. But life safety systems could be here. Look, unit equipment for emergency lighting, exit sign, fire alarm system. Do we need to protect conductors? No, it's not a high building. Only if it's not a high building, only conductors protecting for a fire pump. Right? Otherwise, we don't have to do it. Second, I'll just finish and you ask. Second question is, wow, what do we do by means of protection? Building process, we have 2 means. Those conductors which require to be protected could be put in a space or shaft which is 1 hour rated, right? And you cannot have any combustible stuff. So interpretation came, you cannot have any conductors, only those which require to be protected. I disagree with it, but because if they're in a raceway is non-combustible, metal raceway. It's electrical equipment.
So
But, yeah.
if, say, we have fire alarm cable inside the conduit,
Yeah,
and this conduit can be considered as 1 hour fire rating.
I think code said is if the conduit in the concrete is above is 50 millimeter, deeper or something, thinner, it's considered
No. So there are 2 means. Number 1, if you have circuit integrity cable, cable which by design and construction has insulation, where it during elevated temperature it expands and becomes foam and protects conductors. So those are more expensive conductors, but they can work. In this case, you don't need concrete, you don't need anything. So you just specify those conductors, and it's very, very simple. Or if architect has a shaft, 1 hour rated shaft, 2 hour rated shaft, you can put those conductors. That's it. Equipment will be in service rooms, which must be fire rated.
to conduct conduit concealed in the concrete is considered like a fair rate, right? Because non-sigil concrete like slab
Yeah,
to
yeah.
2 hours.
Agreed. Yeah, because conduit in a concrete actually is located outside the building, essentially. Because you understand, you even have high voltage conductors come in the concrete, so they treat it almost like being outside. But normally they use in shafts because in shafts it's cheaper. And what you do, why would you put so much concrete? You create shaft and allow conductors to run, then replace. But it could be embedded in concrete. It's not up to us, it's up to building designers.
I mean, for the branch like circuits, it's we mostly do the concealed conductor in the concrete slab
But
or the beam.
Where, give me an example.
For example, this building, they do not put a surface market inside in the serving. It's inside the concrete slab.
Okay, but these conductors serve what?
What do you mean 19 something? And I understand you explained to us we do not need that part, but only like a rider. You need that.
Yeah, we only need conductors to get the equipment itself if it supplies firefighters, elevator, smoke control, smoke management funds, then we need it. Otherwise, here, we don't care. What's the point to waste money if all equipment burn? Because you have to immediately leave this floor. Maybe 50 other floors have to stay. It says that we have voice communication. You understand?
I have a question. Can you share some experience about how to use Canadian electrical efficient? Because I'm an electrical designer, so when it comes to a design, it's impossible to understand or read all the sections that required by electrical. So I just do the design. When it comes to the net protection, things go down.
Before you do something, you have to have basic training. I'll give an example. Let's say my wife tells me, make seafood fettuccine. I can fry eggs, but I don't know, of course I can make seafood. I'm just joking, you understand? So, I have to be trained. So somebody has to tell me, somebody has to show. So tradespeople normally go and take code course. We just had a little bit, but it's a brief code course. But now, if you listen carefully, you already know where to go, what to look, and you have a book. George will give you this book, and you have a code book. You understand? And experience comes. I remember most of the rules by heart because I deal with it as an inspector. I deal with it for many years. And I help designers all the time. Of course, if you are not prepared, it will be tough. But eventually, when you start cooking your seafood fettuccine, your pizza, you're getting more experience. It will become much easier. So, what I would suggest, go and take 40 hours code course. BCIT offers code course in Berlin. You can go and do it on every side. And it comes, all of us, we go through all that stuff. You start doing, it's like driving. Now you do it automatically. So it's only experience. And what you do, because when you do design, what criteria do you use? Somebody says, design for me, let's say, this daycare facility. So what do you do? Or how would you start? Would you tell me?
Set up a drawing and do the lighting over parallel. And I can use the previous project as a reference.
Let's say you do of a restaurant because it has equipment. Somebody says, could you design electrical distribution of the restaurant? So you have to know what your loads are. I have to stay in such a way. What are your loads? Get information of all your loads. Then basic loads, lighting and receptacles. And basic loads, you have to know based on table 14. It tells you how many square meters multiplied by. You compile all these loads and say, okay, we discussed it today. Now we have to put panel board based on loads. Then you know that if your panel board or current protective device marked for 100%, you can buy panel board which will be not smaller than your load. Then you look at layout and see where client wants to. So you understand? It's step-by-step pieces. But normally you work with person who already dealt with it. Person who already it. And next time. But those are main components. And design is based on 3-4 conditions. Safety, which is electrical. Why safety? Because safety is not data, it's a law. Second, economics, right? We discussed. Third, sustainability, because now it's mandated by the federal government. And finally, specific conditions requested by the client. That's it. But those are three criteria. George told me 20 to 8 or 9 be in his office this morning. He didn't tell me to swim, to run, to take a bike, to skate. He set up performance requirement. Be safe, be capable to provide instructions, and be on time. He didn't tell me that when you do design, you have to deal with prescriptive requirements because you have specific cooking recipe, which is if somebody wants you to, did you have people coming to your place? Did you host? And you say, oh, you have to cook, you have to arrange something. So you have to know how to do it. If you don't, you go catering service. But it's exactly how it works. Step by step. But deal with your senior peers, and slowly, they will give you more work. Because otherwise, and don't be shy to ask questions, because otherwise, you waste your time, waste company time. And if you don't know, don't say, I don't know, help me. That's it. It's obvious. Step by step. And don't be afraid to ask questions. People will come and help you right away.
Ark, I got a question. We have some potential project for remaining big costs. So a client try to increase their service size. They try to install customize a substation in their house. So we need to put switch gear for minimum voltage, transformer and low voltage and switch gear. Can we just put it in an existing unit without an electrical room to house it? Or we have to add an electrical room in that unit and then put the electrical equipment inside?
You can put high voltage equipment anywhere you want, provided it's accessible only to authorized people.
Okay.
And there is no live parts. But also, when you put high voltage equipment in this room, you're creating high voltage station.
Yeah.
So you need a loop in a ground around.
Yeah.
You need station ground electric.
Right.
We will have many high voltage stations, service rooms, which have low voltage equipment. distribution transformers, from boards, as long as you have enough place. And if it's a dry type unit, you can talk to Schneider.
Yeah.
They will give you a package unit substation. They will actually come assemble it.
Yeah.
And that's it. This is will come connected to service compartment.
I mean, from life safety perspective, do we need a dedicated electrical house?
It is in Vancouver.
Yeah, in Vancouver.
In Vancouver, when I was there, I made a building. Only high voltage equipment must be, so fire alarm communication equipment, other equipment is not allowed.
Oh, so you have
In
to
Vancouver.
dedicate.
I wrote this building because one person was electrocuted.
Okay.
They
But
have-
what about we use like customized unit substation? You have minimum voltage switch here, transformer, and low voltage.
You can do
Yeah,
it.
it's
Take a look, George. Here's your tables. If you couple them, I don't know, is it one table or it's you have custom built? So you can actually bolt them together, or you can keep them as they are, and they will move around as necessary. So it's up to you. If you tell in a short run, you need a switch here, and this is your main load break, service compartment. This is metering equipment. This is a transformer. Schneider will actually provide shock drives, will bolt together pieces of equipment, will interconnect all conductors, will put neutral and grounding bonding conductor together and bring it together. This is designed and certified to one standard. This is transformer to another standard, low voltage to third standard, but it looks like one big integrated assembly. So it's up to you. Or you can put one piece of equipment here, another normally, traditionally. It's easier, more economical to make a unit substation. And we actually put new definition unit substation.
Oh, okay. So a dedicated electrical room with 2-hour fire rated wall is not mandatory. As
No,
long as you put a fence,
no,
to-
no.
That is required if the fire alarm control panel is in the room as well.
But
Do you hear?
let's say you have minimum voltage or high voltage equipment over there, you don't need a fence or barrier.
No, because it's all metal clad. It's before, you remember, we have open wiring, big buses, oil field transformers. Then we say, hey, open wiring must be accessible only to authorized people. No, it's like you go outdoors, there is a unit substation, there is a box, you don't even know what it is. Same here.
Okay, then why we still need a service room, a dedicated service room for electrical, mechanical housing, and they
Only
need to be
convenience.
fire rated?
Only convenience.
Oh, okay.
Number one, but only if it is a life safety equipment, fire pump,
Oh,
smoke control, distribution for smoke control, MCC, and we want this equipment to work in fire conditions.
Okay.
It has to be 1 hour rated.
okay.
This is
I see, that's.
because we're protecting conductors too.
Oh,
Yeah, otherwise, if building is sprinter and there is no life safety equipment, just normal supply,
okay.
you don't need fire rating, but consultants know, architects.
You need code consultant.
Oh, they're supposed to know, but in general. In Vancouver, everything is sprinter, but it's a service, it's convenience. Of course, you don't want high voltage room to be accessible to tenants. So we put service on your key.
I conduct one for the gas furnace. Actually, I do have some project before. The people do that way. I have left it. For gas furnace, they ask for the emergency shutdown. They push back outside of the mechanical room. So is that requested by code? I don't know what's the purpose actually.
And it's part of, there is a code for oil burning
Or
and gas burning equipment. It's B149, B170, 149, and 149,
149,
yeah,
449.
B149, and B109. And it has all bunch of requirements. So all those requirements in this document. So when you buy a standard, it tells you exactly what it's supposed to be.
Okay, that indeed emerging the shutdown with a push button for this.
That is part of this requirement.
Okay.
If you have something in electrical code on rewiring in section 28, I'll show you. 26, I'm sorry. 26, 800 series room.
Few minutes left. Okay. I mean, you need to leave.
I know,
20
but
minutes.
2 seconds. Oops, my wife, just give me a second. Here. No. I'm in about 10 minutes. Okay. Bye. Okay. 26. Okay. Take a look. So you can see heating equipment here. It tells you exactly how to deal signals for heating equipment, appliances exceeding 1500 volt. And it does take a look. Shutdown, nature of shutdown. You'll take a look. I have to run because what happened, I have 94-year-old mother-in-law. She's got many problems. And my wife went to work. And so she told me she hasn't eaten and she doesn't feel well. So I said, I'll be at 3 o'clock. And I said, oh, look, what do you do? It's part of it. Okay, folks. But we'll stay in touch. I'll send you all the information. Okay.
Okay. Thank you so much for you.
You know what? It's very difficult in one day to go through all that stuff. But George and I deal with for years. But and again, for a typical code course, as I said, most should go to school and work on it.
Okay. Thank you so much for your great seminar.
I feel
Please
terrible.
accept
Come on.
this small gift.
Thank you so much.
Yeah, I believe everyone either here or
It's a compliment.
online will already benefit a lot from Ark's seminar, right?
But George, as we discussed, key is to understand. When you understand, you can tackle everything. You will find it, you know where, what, and how. And key is to understand. Don't try to remember. So it's most important.
Okay.
If you don't understand, Google.
No. Certain things you cannot do.
Oh,
And in fact, I even tell people, don't go to the handbook because handbook can create many problems.
Oh, okay.
It's,
That's the first time I hear. Yeah. I never read a handbook.
No, I don't trust handbook because handbook is written by one contractor. It's not a consensus-based document. And handbook is not a legally adopted code.
Oh,
And I found so many mistakes in the handbook.
okay. Remember, okay? Okay.
Thank you so much.
Thank you.
George, we'll stay in touch.
Yeah.
Folks, if anything, George will call me, but I'll send you a bunch of articles.
Okay.
Take-
Also, thanks everyone for attending this seminar.
Thank you.
Thank you. We'll keep in touch.
I hope,
Yes. Good.
I hope it was useful. I don't know, but
Oh,
in one day,
they have a lot.
but problem is, it could be overwhelming. You understand?
Yeah.
And
Well, we may arrange other seminars in the future. Yeah, we'll talk about that.
But of course, I'll send you as a comment.
Okay. Yeah.
Thank you so much.
Oh, you're welcome.